Good morning from Bainbridge Island, just west of Seattle, or good afternoon or good evening, depending on where you are on the planet. Welcome to the 15th Annual CAFE Foundation Electric Aircraft Symposium, co-hosted by Vertical Flight Society. My name is Yolanka Wolf, and I'm the Executive Director of CAFE Foundation and the organizer of the conference. Before we get started with our program, I want to take a few minutes to tell you about CAFE Foundation. CAFE stands for Comparative Aircraft Flight Efficiency. Founded in 1981 by the Experimental Aircraft Association Chapter 124 members at Sonoma County Airport, for 40 years, the nonprofit CAFE Foundation has supported the development and implementation of clean, efficient flight. Next slide. CAFE Foundation's mission is to advance the development of low-emission flight by fostering and promoting early entry practical market opportunities. CAFE focuses on three areas: technology, business and marketing, public education, and advocacy. Next slide. During the 1980s, CAFE Foundation, with support from EAA, ran the CAFE 400, a flight efficiency prize competition in which aircraft flew a designated course and were scored based on a formula of velocity times miles per gallon times weight. The CAFE 400 popularized such innovations as high-intensity ignition systems, lean of peak mixture settings, laminar flow surfaces, and many others. Next slide. In 1992, EAA proposed that CAFE should turn its talents towards performing comprehensive flight tests of the most popular experimental kit aircraft. To enable this, EAA funded the building of the CAFE Foundation Flight Test Center at Sonoma County Airport. CAFE Foundation produced numerous aircraft performance reports for publication in EAA's Sport Aviation magazine. These were the most comprehensive reports available on small aircraft at the time and included measurements of the aircraft's flying qualities as well as a thorough set of performance parameters. Next slide, please. For the last 15 years, CAFE Foundation has turned its focus towards electric flight. In 2011, CAFE Foundation hosted the NASA Green Flight Challenge at our Flight Test Center. The purse was $1.65 million. The largest prize in aviation history. The competition was also sponsored by Google, who installed the electric aircraft charging station at the hangar. The competition marked an historic achievement in aviation, the first demonstration of practical cross-country emission-free flight. Next slide, please. Team Pipistrel's winning four-seat electric-powered aircraft, the Taurus G4, flew nearly 200 miles nonstop while achieving just over 400 passenger miles per gallon equivalent. Next slide. Team eGenius came in a very close second for the Green Flight Challenge and also won the Lindbergh Prize for quietest aircraft with a peak takeoff noise of just 59.5 dBA at a 250-foot sideline. Next slide. In 2007, we convened our first electric aircraft symposium in San Francisco with 9 speakers. This annual conference brings together industry leaders to share the latest developments in electric aviation to reduce aviation's environmental footprint. The conference has grown over the years and has moved from its original home in the Bay Area to Oshkosh on the weekend before AirVenture begins. Last year and this year, we turned to a virtual format, which has allowed us to expand our number of speakers and include more speakers and audience from around the globe. Next slide, please. This year is the 15th Annual Electric Aircraft Symposium. For the past few years, Vertical Flight Society has joined us as co-hosts of EAS, for which we are so grateful. This year's EAS will take an in-depth look at passenger and cargo markets for electric-powered aircraft, batteries, cargo, commuter and regional applications, emergency services, the pilot pipeline, workforce and diversity, community integration, among others. The EAS program will also take an in-depth look at aircraft certification challenges, in addition to battery electric, hybrid electric, and hydrogen fuel cell propulsion systems. This year's format will consist of 3 half days, each made up of 6 panels with a break in the middle. Each panel will include presentations from 3 speakers and a moderated Q&A. We have 60 presenters and moderators who will share their expertise with you. Quite a growth from that first year of 9 speakers. Our list of panel topics are shown here, and there's more information on speakers and registration at the symposium website, electricaircraftsymposium.org. And with that, I'm going to introduce Mike Friend, who has some exciting news for CAFE Foundation. Mike Friend retired in 2014 after a 36-year career with the Boeing Company, and has since worked as an independent consultant specializing in aircraft configuration development. Mike currently serves on the technical advisory board for ZeroAvia, working to develop a hydrogen fuel cell electric propulsion system for commercial aircraft. And I'm going to let Mike tell you what else he's been working on and how that has led to an exciting partnership with CAFE Foundation. So let's go to the next slide, and I'll turn it over to Mike.
Yes, thank you, Yolanda, and good morning. I am one of the founders of BACE, the Bremerton Aviation Center for Education, which is a project of EAA Chapter 406, the Olympic Rainbirds. And the motivation for forming BACE was to go a step beyond the EAA's traditional role of introducing youth to aviation through the Young Eagles program. So the intention with BACE is to have an immersive program to design and fabricate electric aircraft as a way of bringing youth and EAA members into the world of low emissions aviation. In the course of setting up BACE, there have been a lot of discussions with the CAFE Foundation because there appears to be a great deal of synergy between what BACE is trying to accomplish and the CAFE Foundation's traditional focus on electric and low emissions aviation. So we're really proposing a joint activity based in Bremerton, Washington, which is just west of Seattle on the west side of Puget Sound. And we've created a facility that we intend to work with the CAFE Foundation on to create an evaluation center for electric aircraft. So much in the way that the CAFE Foundation worked in the 1980s and 90s to provide comprehensive test reports and performance evaluations for experimental aircraft, we intend to work with CAFE Foundation to provide the same sort of service for electric aircraft. So one of the things we're proposing is to have a defined evaluation flight test course that would connect Bremerton National Airport with the Olympia and Chehalis airports, which are being equipped with electric aircraft charging stations. So the idea is that this would be open to any eVTOL or conventional aircraft maker who really wants to have some transparency in the performance of their vehicles. And you know, we really want to leverage the long legacy that the CAFE Foundation has in terms of being able to instrument and test aircraft and write comprehensive test reports on their performance. And I think in these early days of electric aviation, I think this kind of transparency is vitally important. Up until now, with a lot of the eVTOL and electric aircraft programs, there's not been a lot of transparency. And I think the example of the Green Flight Challenge in 2011 that was held by the CAFE Foundation is an example of the way that these kind of public demonstrations can really open the world's eyes to the potential for electric aircraft. So our intention is to work very closely with the CAFE Foundation, and there will be more announcements as time goes forward. I should mention that one of the projects for BACE is the design and fabrication of a new single-seat electric-powered motor glider, where not only will we involve the base participants in the fabrication of an airplane, but also in the design process as we start from requirements and go through the detailed design, fabrication, and flight testing of this exciting aircraft. So that's a summary of what we have, and thank you very much, Yolanda, for being invited to participate in this seminar today.
Mike, thank you so much. Yes, we at CAFE Foundation are really excited about this opportunity to work with BASE and to return to some of those roots from almost 40 years ago now when we were doing flight tests. So stay tuned for more information about our progress. Next, I would like to introduce Jim Sherman. Jim is the Director of Strategic Development at the Vertical Flight Society, where he's responsible for setting and executing the Society's strategy for promoting membership development and growth. In particular, Jim is responsible for supporting the development of the electric VTOL revolution. And on a personal note, I have to say that working with Jim is an absolute pleasure, and this symposium would not be happening without Jim. So Jim, I will turn it over to you to tell us about Vertical Flight Society.
Great, thank you, Yolanda. You're too kind, and thank you for giving us the opportunity to say a few words about the Vertical Flight Society. So, what is the Vertical Flight Society? It's a professional society for those working to advance vertical flight. So we were originally known as the American Helicopter Society. That was formed in 1943. But over the number of years, it occurred to us that we did a lot more than just helicopters, and we certainly weren't just Americans. So over time, we've decided to change the name to the Vertical Flight Society to better represent those things that we do try to advance, which includes electric VTOL, and in this case, just electric aviation in general. We also, with the advent of quadcopters and octocopters, we also address technical issues with larger remote piloted vehicles and drones and the like. So our mission is to expand the knowledge about vertical flight and promote its application appropriately around the world, and advance the safety and acceptability. Safety has been at the forefront of what we do from the beginning, and it's certainly had its moments within the last year or so where safety has come to the forefront again, and we've been working very hard to identify opportunities to improve the safety of vertical flight. We're advocates for getting funding for vertical flight research and development, as well as supporting and educating today and tomorrow's vertical flight engineers and leaders. Those two things are directly tied, as part of that R&D funding goes to our vertical lift centers of excellence, which are Penn State, University of Maryland, and Georgia Tech, as well as about 20 other associated universities that work together on various research activities within the academic community. Our meetings and our other events, we bring together the community of vertical flight, which includes the industry, the academia, and importantly, the government agencies, to tackle the challenges of vertical flight. We are very much not an exclusive organization. We're very inclusive. We allow anyone to join and become part of the family. So we encourage you, if you're interested in vertical flight, electric flight, please consider joining. And if you're part of a larger organization, have your larger organization become a corporate member. We've been very successful in recruiting members over the past year through these forums that are virtual, and we'd like to continue that. And I think we've made some enormous progress just in advancing the industry as a whole through these, shall we say, interesting times. So we can go to the next slide, please. Back in 2013, we started working with the NASA folks on the Transformative Vertical Flight workshop, and that led us to, I believe it was in 2016, where the Vertical Flight Society started the eVTOL.news website. This was intended to be a news site, and as there was very little, if any, coverage of the activities that were going on with electric vertical flight. As part of that, we created an aircraft directory, so you can see that on that website. And as of a certain time last night, there was 484 aircraft cataloged on that website, and you can see the different categories there between vectored thrust, wingless, lift and cruise. We don't discriminate on design, so there's some very silly looking designs on there, as well as some serious designs like the two you see in the pictures to the right there. We've also cataloged a number of companies that are working in this space, or individual designers, as there are a lot of folks that kind of do this as a hobby. But we've cataloged what we're aware of on that website. We've also captured all of our articles, so we have 450 plus articles on eVTOL, and that's not exclusive to eVTOL. There are several that include content on STOL and eCTOL. So we do get in. We are very interested in what's going on in pure electric aviation, as opposed to just vertical, because there's a lot of synergy with the various different systems and designs. There's also a timeline as well as a number of videos on the site, so recommend you take a look at that, and we continue to update that daily. So if we can go to the next slide, please. We have a lot of online resources between the eVTOL.news and our Facebook and Twitter and YouTube and Instagram and Vimeo sites. We post to them constantly. I know Mike Firstberg, our executive director, posts to the Facebook site probably once an hour, if not more often than that, as well as Twitter. And you can follow us on any of those sites and get the latest information as we receive it to keep up to date on what's going on. If you also go to the eVTOL.news website, you can sign up for our Electric VTOL newsletter. It comes out twice a month. Contains a lot of the latest news over the past two to 3 weeks, as well as links to upcoming events and plenty of other excellent information about what's going on in the industry. We also have a number of videos and presentations throughout our website, as well as the Vimeo and YouTube. Over the past year, we've added probably most of those 160 plus hours on our YouTube website, and through these webinars, various free webinars and some paid ones too. So if you really want to get up to speed, I recommend you go there and just click on the playlist and go through each of those. So we can go to the next one. We have some events that we hold. Obviously, this one here at the top is Cafe VFS Electric Aircraft Symposium this week. We also hold biannual workshops on electric VTOL infrastructure, as well as our eVTOL Symposium, which this year will be part of the Transformative Vertical Flight 2022, which will be our first in-person meeting since the last time we met in San Jose, California in 2020. And that will be held January 25th to the 27th. The abstract deadline has been updated, and I missed this last night. Sorry about that. It is now August 2nd, so please consider submitting an abstract to be part of the program. We're looking at doing some other special activities there too, so stay tuned. And then obviously our annual forum comes in every year in May. So if we go to the next one, or that might be it. So we've been covering this space for a very long time, and our 6 times annual Vertiflight magazine, member magazine, has captured a number of stories and have featured eVTOL and advanced vertical flight on its covers, and this is just a small sample. So again, if you are interested in eVTOL or electric flight in general, please consider joining Vertical Flight Society, and I yield the floor.
Thank you, Jim. Jim, did you want to mention a few housekeeping items before we go to our first panel?
Oh yes, I'm sorry. I got caught up in what I was doing and forgot what I promised to do. So yes, as part of this webinar, you are free and encouraged to ask questions of our panelists. In your control panel, there is a question/chat box. You are free to pose questions to our panelists through that chat box. We will not be taking verbal questions today, so that will be your only way to reach and provide additional questions. Our moderators do have some questions already assigned, but they will be taking preference from audience questions. Other than that, you feel free to try to chat with people too, and then look forward to seeing your questions and interacting with you throughout the day, throughout the week. Thank you.
All right, thanks, Jim. And can we go to the next slide, which should be our first panel? Wonderful. So our first panel today is going to provide us a global overview of the industry. For those of you who follow the industry at all, you know that this industry has grown incredibly over the last few years, and even in the last year, since the last time we had this conference, we've seen an amazing amount of growth, both in the development of vehicles, in flight test hours, and also in investment dollars that have gone into the industry, and industry and non-industry partners that have stepped in. So we're going to hear from three panelists today. I'll introduce each of them just before they speak, and we're going to start with Mike Hirschberg. Mike is the Executive Director of the Vertical Flight Society, and in that role, he represents the vertical flight technical community and advocates for the advancement of vertical flight research and technology. He's the publisher of all society publications, including Vertiflight, the Journal of the AHS, and annual forum proceedings. And Mike, I will turn it over to you.
All right, thanks so much, Yolanda. You can hear me okay?
We can.
Yes.
Excellent. Well, thanks everybody for joining us. Really happy to work with Yolanda and the CAFE Foundation to help educate people on this broader electric aviation revolution, and I'm going to speak specifically on the electric VTOL revolution. Next. So, there's been lots of terms. Uber, when they came out with their white paper in October of 2016, really focused on the air taxi mission. But we've really, as a technical society, we've really focused on the propulsion system, which we see is really the transformative capability that allows configurations that have never been able to be practical before. So, it was UAM, now more expansive. It's AAM. People keep trying to come up with different acronyms. We're focusing on eVTOL and the electric VTOL revolution. But the electric technology, electric power really enables all these different types of VTOL configurations. Next. And, there are some electric helicopters. That's not really what we're talking about. The magic, as we see it, of electric power allows you to get rid of all the complicated and heavy and expensive parts of a helicopter. So the control systems, the transmissions, gearbox, shafting, hydraulics, etc., and really replace that elegant, complex rotor system with multiple single kind of dumb propellers or more simple thrusters. And battery power is battery power isn't very good. It's about 5% or so of the specific energy of fossil fuels. But for those configurations that have wings, you can really gain back a lot of that efficiency by converting to wing power and getting the aerodynamic efficiency for higher speed and longer range. On the left, you see a picture there of the Sikorsky Firefly back 2010. They never flew it. They did some initial studies on electric electric power. And what you see on the floor is all the things that you take out when you get rid of the combustion system, the engines, the exhaust, the drive systems. Sorry, not the drive systems, but the fuel systems. And then if you kind of take that one step further, you can see if you can get rid of then the complexity of propellers, then that's even more reduction of complexity. Go to the next chart. I'm having a problem with my computer. And just, here it shows two different propellers on the right. So this is just a fixed pitch propeller for EHONG. And at the bottom, it's a variable pitch, collective pitch control for the Joby tilt propeller. And we really should focus on the word propeller, right? So a propeller is generally not designed to fly at high speeds horizontally. That's why you have the complexity of the rotor system, because it is a lifting device, and it is what is propelling you forward or in whichever direction you're going, as well as providing the lift. So there's a lot more complexity with a helicopter rotor or a tilt rotor. Next slide. Now, eVTOL isn't new. Maybe it's new to some of you guys, but this has really been going on for more than a decade. Here shown on the left are some of the different configurations. The top left is a concept study, but the other ones are all electric VTOL or electric vertical flight aircraft that got off the ground in 2000 and really mid to late 2000. Just one caveat there for the unmanned Project Zero. It didn't look like that when it first flew. That was the completed configuration. Originally, it was more of the frame of it that flew. But you can see here, it's things that people have been working on this a long time, and things have progressed a lot since over the last 10 years. Next chart. Now, this is a study that we did with Aviation Week, Graham Warwick, and looked at all the concepts that were on our website, our eVTOL.news aircraft directory in August of 2020. So there were, at that time, 350. Now we're up almost to 500. So it's only gotten more since COVID, which is surprising. But the first column shows, there's all these different concepts. Some of them have flown at larger scale. But very few. So at the time, only 12 had prototypes that were actually flying. And at the time, there were there were 3 that had built large numbers. So about 100 or so had been built. Now Kitty Hawk is no longer developing their flyer, but they've got their the heavy side that they're flying now. Okay, so next chart. And I'm just going to look at show some different ways to look at kind of the progress of vertical flight. So this is another way to measure it. Okay, the companies that have gotten a lot of money. These are the top 6 companies who've gotten investments. Having this vision for this electric aircraft revolutionary capability is never going to get anywhere if you don't have the money to back it. I think most people have known that it takes about $1 billion to develop a clean sheet aircraft and certify it. Our analysis has actually shown that, from looking at workforce, you'll hear a bit about workforce today and also on Thursday. You need about 1,000 employees, and more than half of those engineers. Probably about 2/3 are engineers and people with technical backgrounds, and about 10 years. So $1 billion, 1,000 employees in a decade to develop a brand new aircraft. Now, that's a rule of thumb, so it's generally kind of about right, but specifically it's always going to be wrong. But something to keep in mind, and that's just to get the certification. So you've got to scale up for production, build out your infrastructure, and the end goal of anything is you want to make money for doing it. So there's a lot more things that are required. Now, you see here where it says pipe and cash. So that's with a special purpose acquisition company, a SPAC. Now they do have large transaction costs, so I didn't include that here. This is the top amount, not necessarily the amount of money that the company will get to do the development, but the amount of money that was raised. Next. And this is a summary that a Twitter user developed and adapted for us. And I'll just have some of these up on the screen. You guys can take screenshots or look at the recordings of them later. But this has some of the details on the company plans for production. Next. This shows, just an example, and this was, I think, about 6 months or a year ago that this was shown. But Joby is arguably the leader in the eVTOL revolution. It shows the amount of work. This is just talking about certification, and after 10 years of development, and you can see on the right-hand side, so they did about 700 flights of their subscale, 200 some flights of their unmanned full-scale prototype. And now they've done, I think it's somewhere, well, I'll say hundreds, but somewhere between the two, the first generation and the second generation, I think they've done about 1,000 flights. So you can see they've done quite a bit of development, but they really show here from the risk reduction and progress, they consider themselves to be kind of halfway done with getting through type certification as far as number of flights and hours and things like that. So it's a long path. People shouldn't be thinking about this as a get-rich-quick scheme or something that's going to be really easy, just because it doesn't have some of the complexity of a helicopter. Developing a new aircraft and getting it certified, and especially something that's novel and hasn't been done before, is a lot of work. It takes a lot of work and energy and effort and time and money. Next. A couple other things here. Again, you can take a screenshot of this. This is actually from one of our recent articles in our magazine. Jim mentioned some of our different, or shows a picture of some of the different magazine covers. In our most recent issue, we got to focus on infrastructure, looking at a helicopter heliport, and a lot of eVTOL companies are also looking at that, and the lessons learned from helicopter heliports. So lots of companies now, here's kind of the leaders as far as some of the getting passenger eVTOL for development, the investment, and also lots of orders. So these are, of course, conditional orders based on them actually being certified and having, whatever the minimum guaranteed performance specs are. But it does show that there is a lot of interest from some of these largest companies in aviation, United, American Airlines, Virgin, UPS, and Blade. So lots of interest, and this is really going to happen. It's going to take a lot of effort, and there's a whole ecosystem that needs to be developed. But it's really exciting to see it all come together after all these years. Next. Some other ways to look at this. So SMG Consulting, Sergio Sakuda has been publishing for the last, I think, since December, so last 8 months. His top electric companies, it used to be eVTOL, but he's expanded it to STOL. So it's the AAMRealityIndex.com. Currently, he's got the top 20 companies. You can see here how he's used to rack and stack these, and he updates it every month with the latest progress, and continues to add more aircraft and more updates as more information comes to light. Next. So, why now? I think everybody here knows. I mean, there's been tremendous advances in electric motors, batteries, democratization of computer modeling simulation. Used to have to have a major OEM had a huge mainframe to run their simulations, and now you can do that on a desktop with commercially available software. Obviously, advances in composites, low-cost manufacturing, the FAA and EASA change in performance regulations, all these different technology innovations, and I mentioned money, right? So it's about $5 billion we had tracked through the end of 2020, and we've hit about another $5 billion of planned investment through the SPACs and other investments just in this year. So $10 billion now going into this industry. So all these really enable new configurations and innovations. Next. So, is this eVTOL revolution going to succeed? Well, bottom line, right, you got to make money. So you got to have low operating costs per seat mile. We know that batteries are improving. the first aircraft might not have great performance. Ones in 5 years will have better performance. And we're also hoping that hydrogen will come online. So hydrogen fuel cells would really be a killer app for eVTOL. In the end of the day, they've got to be cheaper to manufacture and much cheaper to operate than a helicopter. And really the key attribute that eVTOL provides that helicopters have held helicopters back is really the noise. If you can have the promised noise reduction of 100 times quieter than a helicopter, then you can fly it in higher density locations, and everybody will be happier from that. Next. So when I started briefing this chart like 5 years ago, there was these 5 key challenges, and for the most part, all these were being addressed. So technologies have improved. We've done a lot of work with infrastructure. That's all coming together. Workforce, we recognize a pilot shortage. Organizations like CAE and Lufthansa are developing training programs. One thing, and I mentioned before, we've been raising the alarm on engineers, trying to get more engineers into the workforce. Standards and regulations have been in development. GAMA and other organizations, SAE, ASTM, have been developing standards for application for eVTOL. Public acceptance. Yolanda is a co-executive director for CAMI, the Community Air Mobility Initiative, which is working with localities to get them to understand the benefits of eVTOL and how to embrace that. And of course, there's this rush for first mover advantage to try and drive it along as quickly as possible. Next. But it's also important to think of where we are in the development timeline. So I showed you before 2011, we were kind of at that first hover, and that's looking at the kind of the first helicopters or prehistoric helicopters that got off the ground. Volocopters now been demonstrating. There are different volocopter demonstrators for the last several years. They've got a production prototype plan. I don't know that it's flown. They haven't announced anything, but presumably it's ready for flight or almost ready for flight. And they've got a more advanced product that's ready for longer range, medium range flight. So you compare that to the helicopter. The first helicopters were kind of ridiculous, but now today they do tremendous work. Next. So, the electric VTOL revolution is like a moonshot, but we landed on the moon, and we're going to do this. We're going to be successful for eVTOL. There's 1,000 reasons why eVTOL won't work, but we're working to bring the community together and working with all the different organizations to find solutions to make them to find the path that will work, that will make this a viable future. And it's going to take everybody's efforts. Next chart. We're leading a lot of the eVTOL work, but it takes a village. I mean, it takes everybody's work. It takes your work, your engagement to make this successful. So join this electric VTOL revolution. You can join the Vertical Flight Society or any of the other membership organizations and help advance vertical flight and help realize this advanced air mobility future. So with that, I turn it back over to Yolanda.
Wonderful, Mike. Thank you so much. Our next presenter is Vili Taki. Vili is the founder and CEO of Flying Pages. He has been working for aviation publications since 1983 as an editor, test flight editor, editor-in-chief, publisher, and presenter. He is also the organizer and founder of the annual eFlight Expo at Aero Friedrichshafen and in China. And it's my pleasure to welcome Willie.
Thank you. Sorry for this, and thank you for having me again here. And sorry for being a bit late with all my presentations, but I will show you, please, next slide, why we were very busy. Because if you see the big red aircraft there, the Directory of Light Aviation, this is what we just put together, and it just went to the printer on actually the last pages yesterday. And there will be a lot of electric flying and an overview. Again, it's like every year in German, English, and French, and will be out in Chinese as well. And as you see with the other magazines, you see there, like we have some more magazines, mainly on ultralight. and microlight, but this one's like the eFlight journal, which is printed always at the big shows like Oshkosh, Aero Friedrichshafen, and our event in China. And we have the Flying China magazine. And due to the pandemic over the last years, it's nearly years now, we didn't see us all, so we try to get the information out also in digital form, but also in printed form. Next slide, please. Like Jolanka mentioned, we have several events, which, for example, the eFlight Forum is the one we put in most effort over the last, since 2017, together with the eFlight Expo. And now last year we only could hold it as an online event like the EAS, but we had a lot of people from around the world participating, and we try also still to connect China, because there is a lot of things happening there. You will hear from my colleague later on. Next slide, please. So these are the items I'm going to talk about. So let's go to the next slide, please. So you all know that about 2 years ago, EASA released their VTOL, which is actually the first authority around the world which has a special paper just mentioned on VTOLs. Other than FAA, as most of you will know, they have some eVTOL in the helicopters, some eVTOL in the fixed wing certification class like FAA Part 23 or Part 27, and but EASA has issued a special VTOL. Next slide, please. This is all known, which shows you now just a quick as a reminder for those who are not so familiar with EASA. Everything which has about up to 2 rotors, it's counted as helicopter. Everything which has more than 2 rotors, counted as VTOL. And they especially say not SCE VTOL, they say VTOL, as theoretically you also can still have it with a combustion engine, but up to now there are no really people who have some aircraft which will not work with electric. Next slide, please. This is actually some news, because like now EASA has issued several means of compliance, and this is the latest one. And if you want to check, if you just type into Google EASA VTOL MOC, and then you will get the site where you always get the latest updates. Next slide, please. Because they also have not only issued it for the VTOL, but also issued it for the electric propulsion system. And this is something which already happened last year, that Pipistrel not only got their aircraft in CSLSA with an electric motor certified, but also having the electric motor certified in CS22. Next slide, please. So showcase project, we can go through some. I'm not complete because there are so many small and larger ones, but next slide, please, and you will see those which are there. One is Pipistrel, where you have seen the Velis, which is now sold around the world as it's a CS class in Europe, this LSA. So in Europe, you can fly it in all the countries where EASA is the relevant authority. But Pipistrel also started to their cargo service with the new Nuva, where they have different sizes. And the interesting thing there is that several companies around the world has realized, I think, that it will take some time until we have manned air taxis flying. So they are trying to do, having the same development as the technology is the same, and doing some business with transport of goods, large drones, which are at the beginning not flying downtown anywhere. They are mainly flying on routes where there are not so many people. So the authorities are much more open to allow this. Next slide, please. One thing for the slide before, Xin will tell you more, because especially China, they are running several of these programs, and there is some news there as well, which we hadn't had in our presentations last year. So now we have here, it's not only Pipistrel, it's now other companies coming up with electric trainers. There is one which is, I think, quite interesting. That's an ultralight based on the Electra Solar, which you probably have seen some years ago from Kalin Gologan, which is flying already several years, which was just certified, or not certified, like registers as ultralight, but it's a kind of certification in Germany this year in summer. And now they are announcing a 2-seat trainer, and it's not only this computer image. I've been at their place and I've seen the real aircraft, but they're the mock-up. They are now building with the original molds, the first forms. And the amazing thing in this aircraft is that with 600 kilograms maximum takeoff, with 2 seats, they arrive at what they say, and we hope it's right, 2.5 hours flight times. That would be much longer than at the moment what Pipistrel is announcing. Even if they only do 2 hours, it would be already more than double. And as a lot of flying clubs with ultralight aviation in France and Germany and Czech Republic, I see there a future of special flight training being done with this aircraft as an ultralight. Next slide, please. Another company which was already in some electric project is a company Tecnam. They had a hybrid, but this was just a development of the motor for their Tecnam P 2010. But now in autumn, in our eFlight forum, China forum, which was this year in only online, they announced that they will do a fully electric version of their Tecnam 2012 10-seater. And the propulsion system is supposed to come from Rolls-Royce, and they are definitely working on it. Rolls-Royce is hiring about 70 people for different projects on the electric field. Next slide, please. One thing I also have to mention, we don't have in there also Diamond Aircraft has shown at the same event first prototype of an electric version of the DA-40, which is called DA-40 EP, but it's more or less looking like the normal DA-40, and they are right at the beginning of this development, although they have developed already some electric projects as prototypes before. An interesting thing to watch when we come to the electric commuter class, where also Tecnam is working, is Volta Aero, because they are flying with their modified Cessna 337, where they cut off the first part and no prop in the front anymore, but for these 2 electric motors in the back and a combustion motor plus electric motor on the rear propeller, and they are flying with this aircraft regularly. Next slide, please. Sorry for rushing so through the slides, but we have a lot of things to do and I have only little time. This is a brand new project which was just released very short while ago, because a lot of people are talking about e-commuters in Norway, because Norway, there is along the coast a lot of air traffic and there are no good roads nor good railways. And there is right now, as part of the public transport system subventioned by the Norwegian government, are routes where commuters are flying right now, the businessman along the coast. And as it's all along the coast, these cities, there was a Norwegian company which now thought they were going to build a 10-seater seaplane. The man behind the project is Tomas Bordeskift, who has released already a 2-seat electric aircraft some years ago, which was seen at Aero, and now together with an investor, he's working on this 10-seater, which makes a lot of sense because you have the short distance only. Sure, you have to get the more energy to get out of the water, but on the other hand, you have the advantage that you have very many emergency landing places when you go along the coast, because in the fjords normally you don't have big waves, so they are all potential areas. And you could also fly not even airport to airport from Bergen to Stavanger, you could also fly port to port where you're directly in the center of town. Okay, next slide please. Yes, this is when you go larger even than a 10-seater or 12-seater commuter. There, this is you know, the Dornier 337, and in this no, 328, sorry, the turboprop version, and there are now plans to do an electric version of this with a fuel cell, and it's a joint venture of the H2Fly, which is actually Professor Josef Kallo from DLR, together with the Deutsche Aircraft, which is a company who has the rights on this Dornier aircraft, and they together want to bring it in only 5 years to fuel cell aircraft flying with 33 to 40 seats. So if this is happening, I think this is also be an impact to the eVTOL society, because maybe as we need range there as well, batteries are not there yet, so perhaps we'll have some fuel cell technologies there as well. And there are, I heard about this, I can't tell you who, but there are some large companies investing there, also from the field of eVTOL. So we'll hear about this probably sooner than later. Okay, next slide, please. Another big one is Hart Aerospace. They also go for the big one. It's only 19, it's 19 seat for motors, where a lot of people say right now with battery technology, it's not feasible, but other people believe in it. So next slide, please. You probably heard about this, that United Airlines ordered several of these aircraft, and also other airlines. So people believe in it. They probably believe in that battery technology will get much better. So they're continuing. They have a serious funding, and they also have a team which they put together in United States and in Sweden. Next slide, please. Now we come to the VTOL area, and I keep on rushing because perhaps like this we have some time for questions and answers afterwards. Like Volocopter has, I think we can go to the next slide already, because Mike was also giving this image as well before, but Volocopter, like Pipistrel, also is looking at the freight sector, and they signed a good deal with Schenker, who is a large logistic company owned by the German railway, and they invested heavily into Volocopter, and they want to use this drone with up to 40 kilometers range, and they have very concrete plans to use this very soon. Okay, next slide, please. And Volocopter is also going a step further. They say, okay, we're gonna go cargo. We go with our new prototype to have our short routes where we will have service fairly soon as we have certification, where they received the EASA design organization approval as the first VTOL company. Except Airbus, sure, because Airbus was always design organization. But now Volocopter is also having a winged model for the longer range called VoloConnect. Next slide, please. Lilium. We didn't see much new technology from Lilium recently yet. We heard several announcements. So one is that the former CEO of Airbus is now on the board of directors. They started a cooperation in Florida for a hub where they want to fly. Next slide, please. And they announced also even larger version. So it's not the first, they started with a 2-seater, then a 5-seater, then a 7-seater, and now they're even to a commuter size aircraft, which also should take off vertically with that technology. There are still always people who don't believe, other people who believe still in them, as you see in the investments. We'll see where it ends. At this point, there is a lot of discussion about Lilium, yes or no, and there are two parties which basically either believe or don't believe what Lilium is telling. Okay, next slide, please. Airbus, they haven't released any technical news, although I know they are working on something. They opened a downtown office in the Munich area, which is very nice. And so they are keeping on it, but I think they will not be the fastest mover, although they have also, again, registered some additional patents. And my bet would be that the next Airbus eVTOL will have wings again. Okay, next slide, please. Vertical aerospace, we've seen quite a bit of them in the charge of Mike, especially on the investment side. On the technology side, they teamed up with Rolls-Royce for the propulsion system and with Honeywell for the controls and certification. So I think a very serious competitor in the eVTOL area. Next slide, please. Yeah, so I'm through with my products. This is some overview of, it's not only the manufacturers, it's also the government, the EU Commission, and the several test areas are ramping up and should be operative already in the next year. Some are near in the south of Germany, some near Paris, some in Holland. So there are several projects going on. One thing to the aircraft before, it's also because some years ago, let's say 3 years ago, there was some news from Autoflight X, which is like a Chinese-German cooperation. They released their VTOL at Aero 3 years ago. And there will be some news as well, but Xin will talk about this later, as their base is China at the moment. Next slide, please. Yeah, now we come to the events and I come to the end. Just one thing is, like Mike was mentioning, there is some more money coming up to the areas. And I even know from some background information, there is even more, probably not already counted in Mike's accounting, which is coming in. So there is still constantly coming new money into eVTOL, which means a lot of people are believing in it. EASA has had a very interesting Rotorcraft Symposium over the last years. The last time, which was in Rio, was in 2019. As it was so successful, they decided to make a fair out of it called European Rotors, where Aero Friedrichshafen is managing the fairground. Last year was cancelled due to COVID. So this year we hope that November 16 to 18, I will see a lot of them, because we will do the conference program there at the show. I think, Mike, you will be there as well, if possible. So hope to see a lot of you there. And next slide, which is actually my last slide, which is the European Rotors. There is a mistake. This is not the European Rotors, the EU April. I was just updating it because this slide is from today in the morning, because this is Aero Friedrichshafen, and the Aero started a new series on their website where there will be live streamed and partly recorded presentations of manufacturers who are exhibitors at Aero, as Aero could not take place last year and this year. They give their exhibitors a chance to put out the news so that the people can watch it on the website. And the very first one, we're going to start with Rotax, which has also some interesting stuff on the electric side. Tomorrow morning, 10:30 European time. So if somebody of you has time, stay with us there. It's a conference a Zoom conference with journalists. And if not, it will be later as a recorded version on the Aero website. Just go to the Aero website, and then you have the Aero community news, and there you will have over the next weeks 1 or 2 new videos every month with some manufacturers with very interesting news. Also, eVTOL news coming up there. I can promise you, if you go there at the end of August, you will have some really interesting stuff. Okay, and with this, I'm closing. Next slide, which is the last slide, which is just my information. Send me an email, send me a chat, and thank you very much for having me.
Thank you, Willie. It's always amazing to hear your updates. You really know how to keep a pulse on what's going on there. Looking forward to finally getting back to Europe in person.
Okay, thank you.
Yes, our third speaker for this panel is Xin Go. He is the Vice President of Flying Pages and Chief Editor of Flying China Magazine. He is also the co-founder and organizer of the annual eFlight Forum in China. And let's see, do we have Xin?
He was in? Yeah, there he is.
Okay.
Nice to see you. Thank you.
Yeah, thank you, Yulinka. I am Cafe and EAS for this presentation opportunity. My name is Xin Go. I'm with the Willie Tucker at Flying Pages. I know we are running short of time, so in this short presentation, I'm just going to give some brief update of the latest developments of electric aviation in China. Next slide, please. Yeah, I'm just going to run through these 4 points. Next, please. So the first is the rulemaking. The Chinese central government have included electric aviation in a 5-year national socio-economic strategic plan, which is the utmost important plan in China. So we can say electric aviation have attracted the attention of the central government. However, as of today, we have not seen much substantial support from the government yet. Next, please. In detailed rulemaking, the Chinese Civil Aviation Regulator, CAAC, take a progressive while cautious learning by doing approach. These are the list of the rules released by CAAC in the past 2 years related to electric aviation and UAV in general. As you can see, these rules cover pretty much all aspects of design, certification, and operation, both manned and unmanned models. And there have been some positive results of the implementation of these rules. Next, please. So here are some of the results of the CA's latest rulemaking. We can see they have already certified several electric airplanes already in LSA class, and they've already issued several flight permits for large cargo UAV. Next, please. So here I'm just going to run through some showcases. Here we see the RX-1E. That's the first electric aircraft certified in China in 2015. It's a 2-seat in LSA class. Next, please. This is the upgraded version of the RX-1E-A with a larger battery and a little bit longer flight duration. I think it's a little bit over 1 hour, 1.5, I think. Next, please. And the RX-1E team is now working on a float plan version of this electric LSA, and is now undergoing CAAC LSA certification. So that should be quite interesting. Supposed to be the first electric float plane in the world certified, by the way. Okay, next, please. So the X-1E team is working on approximately 3 4-seat electric airplane called RX-4E, currently undergoing CAAC Part 23 certification. Next, please. So now we are at the eVTOL sector. So this is the famous EHang 216. Now, next, please. In the past year, EHang actually has been working heavily on the modified models for public use, such as here, what we see here is the EHang 216F model. F stands for firefighting, and the 216L model, L stands for logistics. Next, please. And EHang is also working on a wind model called the VT30. I think they released this model, this prototype last year, and they have been doing a flight test of this model already. It's a 2-seat. Next, please. So here we have XPeng's eVTOL. XPeng is a Chinese electric car startup listed in Nasdaq, with about, I think, close to 40 billion US dollars market cap. It's one of the 3 largest electric car startups in China. So XPeng acquired a Chinese eVTOL startup last year now, and they have developed 3 generations of eVTOL. Here we see here is a single seat. I think that's the first generation. Next, please. This is their second generation. Oh, sorry. Could we move back? Okay. This is their second generation model, also single seat. Next, please. This is XPeng's latest eVTOL prototype. It's a 2-seat and it's already flying. And actually, they just unveiled last week. Next, please. Here we see Autoflight V400 cargo drone. Autoflight was founded in Shanghai by a veteran in electric aviation, Mr. Tian Yu. He is a winner of the Lindbergh Foundation's LEAP Prize and has designed, built, and certified several electric fixed-wing airplanes under his belt. Now, Autoflight has set up an entity in Germany, and now they are working on a manned version. Next, please. This is Autoflight's V1000 cargo drone. Is also for cargo delivery purpose. By the way, the number here, 400 and 1000 stands for the maximum weight, maximum takeoff weight. So this one supposedly has maximum takeoff weight of 1000 kilogram or 1 ton, and they are working on an even larger passenger carry model, which they are going to unveil very soon. Next, please. Next, please. Thank you. So here we have the national team, COMAC. COMAC, that's China's equivalent of a Boeing commercial aircraft. They have joined the eVTOL game. They launched this eVTOL technology demonstrator late last year. This eVTOL is powered by fuel cell. Next, please. So in terms of supply chain, it's safe to say that there are fairly comprehensive and complete supply chain that the electric aviation needs in China. As we know, supply chain is critical for the mass production and the economy of scale of electric aviation. Here are some key points I think are important for the supply chain for electric aviation. Next, please. So in terms of ecosystem, in terms of supply chain, in terms of ecosystem, we have witnessed the quick expansion of ecosystem of electric aviation in all areas in China in the past year. There are more eVTOL startups actually. So besides what I just mentioned just then, there are actually several other eVTOL startups, and I think they are going to unveil their design or even prototype fairly soon. And there are also homegrown flight control for fly-by-wire use, and hydrogen fuel cell collaboration, and the traffic management or UTM system, and electrical motor companies are also collaborating with the electric airplanes for certification. Next, please. So here we come to some preliminary conclusions. These are some of the advantages I think that the Chinese market have to develop electric aviation. You're welcome to take a screenshot for further view. Next, please. So I think in general, the market perspective for the Chinese electric aviation are that China may have different use cases and launch users of eVTOL simply due to a highly competitive ground-based public transit system such as high-speed rails and the metro system in urban area. And CAAC may have a different rulemaking approach from EASA and FAA, especially in the area of eVTOL. And the Chinese electric aviation market were pretty much driven by a market force rather than policy or the government subsidy. Next, please. So the bottom line is the Chinese market, in my view, should be viewed as a key segment of the global electric aviation market for its market size, supply chain, and investment opportunities, while a conservative and gradual approach should be taken. Next, please. So finally, I would like to mention two events related to electric aviation in Asia, which I did not include in this presentation. The first is the eFlight Forum that we host in China in the past 4 years, since 2017. Last year, we have an online version and it was quite successful. This year, we'll see if we can have on-site or online. Very likely, we have a kind of a combination of both. We are going to work together with Aero in Friedrichshafen in Germany to work on this Aero Asia Expo in March next year in Zhuhai, and there will also be an area dedicated to electric aviation. So hope to see you guys and welcome to both events. Thank you very much. I turn it to Yulenka. Thank you.
Jin, thank you so much. And we have a couple minutes for questions, so I'll ask the other presenters to turn their cameras and mics back on. Because we just have a couple minutes, I think there are a few questions in the question and answer box that are directed to specific presenters, and maybe I'll ask you to take a peek at those and see if you can answer those. I would like to ask the panel a question and have each of you comment on it. Generally, how is the increasing focus on hydrogen that we've seen over the past year changing the industry landscape, and why? So Mike, maybe I'll start with you.
Yeah, so as I mentioned in my talk, I mean, compared to fossil fuel, batteries suck. I mean, they just don't have as much energy density. Hydrogen, we started a hydrogen council last year, and anybody interested in hydrogen for eVTOL or eSTOL are welcome to join. Some great presentations. Hydrogen is really kind of the killer app. I mean, when you have the electric VTOL, you can distribute the thrust around the center of gravity through wires, so it's power through wires. But just electricity, batteries don't have enough storage capacity to really have really great performance. I mean, you could do adequate performance with them if you design it right. So hydrogen can really kind of turn that on its head. And if we can solve all the problems and develop lightweight, small volume fuel cell systems, it's going to really change things for vertical flight.
Thank you. Willie.
Yeah, I think there are two things. The positive on hydrogen, I think, is definitely if you look at the car industry, because some years ago we said, yeah, electric cars won't really work, and they're getting there. Now people saying, yeah, electric cars, yes, that's it, but hydrogen, that's too dangerous, too explosive, and a lot of arguments against it. And I think it's going to work as well, because there are so many logic points which hydrogen is positive. Like first is like for the storage. Second is, for example, here in Germany, like we have a lot of energy which is produced now in the north, renewable energy, and we need the energy in the south. and there is a lot of people who are against a lot of new cables going through the whole country. So I think with having a full hydrogen infrastructure, perhaps also for local storage of hydrogen and then putting it up back to the grid again, I think this definitely is the key of the future, probably even more than battery, because the implications, environmental implications of lithium and a lot of other stuff of batteries are also not that easy. So I think in a medium term, probably we'll see much more hydrogen, and governments, EU Commission, national governments, they're putting tons of money into this at the moment.
Chen, your perspective.
Yeah, I'll definitely echo with both Mike and Willie on this. I think the use of hydrogen in aviation is not a matter of if, but just a matter of when and how. However, I just like to add to this point, I think the how question might be a little bit critical to solve, because in my view, this deployment of hydrogen for electric aviation, for aviation use might be more of a political or even a geopolitical issue rather than technology issue, because we can see that there are companies and countries that already going on this issue. For example, Airbus released their hydrogen aviation strategy going hand in hand with EU's hydrogen strategy. And we can see from aviation, because aviation needs at least 2 points, right? The takeoff airport and the landing airport in order to use hydrogen. Otherwise, the hydrogen airplane won't go anywhere. So in this case, we'll see, I think it will be very interesting to watch in the next few years or even next decade, how this hydrogen backbone for infrastructures will be deployed across the world. Especially in those fossil fuel rich regions. I think that that'd be very interesting to see how Airbus can push their hydrogen strategy. Thank you.
Thank you. Yes, I think infrastructure is going to be a big piece of that question. Well, we have both a hydrogen panel and a battery panel coming up over the next couple of days, so we will hear more about this topic. I want to thank this panel for presenting, for doing a great job in getting us kicked off. And we will move on to our second panel.
Thank you.
Thank you.
See you soon.
Thank you. All right, our second panel today is on the business case for regional air mobility. And our panel will be moderated by Charles Alcock. Charles is senior editor with Aviation International News. He's covered the aviation industry as a journalist for more than 30 years. He's responsible for the editorial content for AIN's FutureFlight.aero news and information service, which focuses on new aviation technology and business models, including electric and autonomous aircraft and urban air mobility initiatives. Charles, I will turn it over to you to run this great panel.
Thank you very much indeed, Yolanka. Very good to be here, and hello everybody. We're very glad that you've joined us to consider the business case for what I call the new wave of regional air mobility. Why do I call it a new wave? Well, before I started focusing most of my time reporting on electric aviation stories, much of my work with Aviation International News was in the conventional air transport industry, and more specifically the regional airline sector. And at the time, the clear trend among regional airlines across certainly more mature markets of the world was to increase the average size of aircraft and replace turboprop aircraft with new regional jets made by companies like Bombardier and Embraer. And if you told me back then, at that time, that we'd soon be discussing exciting new roles in regional aviation for 9-seat aircraft, either purpose-built or converted from piston and turboprop power to electric or hybrid electric propulsion, I would have had a hard time believing that. Well, seeing is believing, and we're now seeing clear examples of just this trend, with low energy and operating costs much lower for electric aircraft, making them well suited to connecting communities. And in some cases, communities that might previously never have dreamed of having any kind of services. So today we're going to benefit from three very different perspectives on this new wave. We're going to hear from a company looking to repurpose existing aircraft like the Cessna Grand Caravan to new roles based on autonomous operations. We're going to hear from a respected independent consultant whose main focus is on the infrastructure requirements around regional air mobility. And then we'll hear from someone with more of a financial background who's working to firm up the business and investment case for what I'm talking about here. So let's start this off by greeting Kevin Antcliffe. Kevin is the product lead with X-Wing, which is a startup whose mission is to dramatically increase human mobility using autonomous aerial vehicles. Previously, Kevin was deputy lead of emerging applications and technology at NASA, where he led the development of a white paper with experts from the industry and academia to cast a vision for regional air mobility. I've personally had the pleasure of looking at X-Wing's experimental operations, delivering cargo and even COVID vaccines to remote communities in America's Southwest. But let's hear the story straight from Kevin, if you please.
Thank you, Charles. You can go ahead to the next slide. Yeah, so good morning or afternoon or evening to you all. I'm Kevin Antcliffe. As Charles mentioned, I'm the product lead at X-Wing, and I've been in this position now for all of 1 week. And he also mentioned I was at NASA and led the development of this white paper on regional air mobility. So I'll be giving just a brief overview of that paper today. But if you have some time over the next few days, I'd highly recommend a quick read or skim of the full report. You can access it very easily at bit.ly/RAM-paper, bit.ly. And so next slide. So a critical element in the development of this white paper was that we found such a groundswell of interest and excitement in this, the potential of this new market from various key stakeholders that were more than willing to collaborate pre-competitively to develop this cohesive vision. And so probably a good first question to answer would be, what is regional air mobility? And so our vision, not just mine, for regional air mobility is to leverage the existing 5,000 plus public use airports in the United States, as well as 14,000 additional private airports to really energize the American travel experience. And so we plan on transporting both people and goods in small aircraft, less than 20 passengers or an equivalent weight in cargo. And we plan to accomplish this by providing efficient, affordable, and community-friendly aircraft. Next slide. You'll see at the top of the next few slides here are several titles. This is just the basic outline of the white paper, and I'll just quickly give a synopsis of each section. And so the graphic to the right shows a few statistics that provide a snapshot of current air travel in the United States. And so there's significant funding going into sustain thousands of airports, but 30 airports currently support 70% of all domestic air travel. So how do we go about changing this? And as the title of this panel is focused on, where is the business case? And so you'll see just a few points highlighted here on the left. A recent study showed that a 40% reduction in operating costs would push this market to a huge expansion. And so if this is the case, how do we go about achieving that reduction? And some of these things have been mentioned, right? Electric propulsion, autonomy, increasing utilization, and really leveraging the ride-sharing economy. And so electric propulsion can provide at least a 25% reduction in total operating costs. Doubling the utilization of these aircraft could reduce total costs by 10 to 15%, just in insurance and minor costs. And these aren't even the biggest factors that could reduce operating costs for these vehicles. Increasing levels of autonomous operations and this ride-sharing economy have been shown to be the two biggest enabling factors in driving the widespread increase in RAM trips. And so these four main factors here can all substantially reduce operating costs for these trips. And all of these technologies and business models don't have to simultaneously exist to increase RAM operations nationwide or even globally. And so the beginnings of RAM has already begun, and each of these technologies will simply increase the potential of RAM to become more affordable and more accessible to everyone. Next slide. So another key piece of the RAM vision is that we are developing a fundamentally new travel experience. And so not many people, I know myself included, enjoy the headache that is current air travel or embarking on extremely long road trips. So we're looking to enable a more distributed aviation system, and the pieces required to enable it have already been built. So there are already seamless booking platforms, non-invasive screenings, operations where you can simply bring your luggage directly to the plane and not worry about it getting ruined or lost. And we also have ride sharing on the ground. About 82% of the US population lives in an area where these kind of services can be found. Next slide. So you're currently attending the Electric Aircraft Symposium. So I'm going to assume that you already are pretty aware of how electric propulsion can impact aviation. Less energy, maintenance, more efficient aircraft designs, engine noise, and overall aircraft noise can be significantly reduced. A few points I will mention on this chart that are specific to RAM is just that electric propulsion and battery technology at this point are particularly well suited for smaller aircraft. And we also mentioned that these 5,000 plus airports across the United States also happen to sit on hundreds to thousands of public use land where megawatts of solar energy fall daily. So let's actually capture this energy and develop a microgrid and provide it to the communities to create a more robust national grid that can better handle cyber attacks and wildfires and things of that nature that we've seen recently, while also future-proofing our airports to be ready for an influx of electric aircraft that will be coming in the very near future. Next slide. So as I mentioned, autonomous systems can provide the most impact in enabling this RAM vision. And I'm not just saying this because I joined X-Wing. It's actually the reason I joined X-Wing. Rebalancing pilots, asymmetric demand cycles, all of this provides kind of a heavy burden on an operator when you're trying to transport these pilots around. Another main factor is that on these aircraft, there are less than 20 passengers or equivalent cargo. And so the relative per passenger cost of having to carry the pilot is more substantial than for a large transport. And so in this white paper, we laid out these two main paths that are on this chart to reach kind of autonomous air transportation. One is SVO, which is simplified vehicle operations, starts with a pilot on board and then gradually moves him to ground control to monitor multiple flights. The other is kind of unmanned aircraft systems approach, if you will. And it starts with a UAS that's operating safety in a remote area or unpopulated, and then just gradually moves him to more congested airspace over more congested airspace. And so this is not an all-encompassing approach, if you will, but one in which we can develop the trust in the safety of these systems and certify in low-risk environments before moving them to more complex environments. Next slide. So I've already talked a little bit about infrastructure here, but just wanted to mention briefly, in 1946, a national airport plan was developed, and I quote, they aimed to build 6,000 public use airports, and they did this so that as many people as possible will have convenient access to air transportation. And it's now 75 years later, and I still don't have, I wouldn't call it convenient access to air transportation. And so, as I mentioned already, let's utilize these airports, develop electric infrastructure at these sites to pave the way for this new air transportation system. Another key point from an infrastructure standpoint is that RAM is not initially inhibited by the existing airspace system. Due to its distributed nature, it can integrate directly into the airspace without a massive change to the current airspace system. And eventually, as RAM becomes more and more affordable, then things such as digital flight rules or corridors or many of the other new airspace constructs will be may be needed then to handle the strong demand for accessible air transportation. And so this next slide is my but what about slide. What about that? What about this? hopefully it helps answer a few questions. The first is virtual presence. There will likely be less business travel post-COVID, and so we must target technologies that lower operating costs so that prices can be low enough to entice personal and leisure travelers. E-commerce is booming, and RAM can take advantage of this as well by providing cost-effective and environmentally friendly options for transporting cargo. Long distance and congested travel pathways are likely to remain regardless of advances in automobiles. RAM will continue to provide strong benefits to the consumer, and automobiles will continue to assist in solving the last mile problem. If there's high-speed rail, so if there's enough demand to warrant a high-speed rail, they'll likely threaten airliners or big highway arteries more than they will the vision that is RAM. We also would welcome and encourage development of rail stations at any of these key airports to help develop a streamlined transportation system. And then larger transports and airports will still be needed for long distance travel. We're just focused on kind of this mid-distance travel dilemma, and RAM will simply provide more seamless connections to them. And then lastly, UAM and RAM both rely on similar core technologies, and therefore both will benefit from developments in and of these technologies. And I see no reason why both markets couldn't provide mutually beneficial services, since they're addressing fundamentally different markets. And so now kind of the last chart here, hopefully quelled any concerns that you may have about RAM. And next chart. There we go. So let me just mention a few things here. I've spent plenty of time on the first two bullets, and so let's focus just mostly on the last two bullets here. When looking at reducing costs or environmental impact, we focus on the current aviation system, and we see that 95+% or whatever it might be of flights occur in a 130 passenger single aisle aircraft, and we target this as the area where our research and development must focus. However, our current trip from our front door to an airplane is exhausting, burdensome, ripe for disruption, whatever words you want to put there. So let's not look at regional air mobility as merely a stepping stone to test out technologies that will eventually reach the single aisle market, but regional air mobility is actually the goal. Regional air mobility aims to provide that affordable, accessible, and sustainable air transportation from your local airport. So next slide, please. And then, yeah, just let's work together to enable this vision. Feel free to reach out anytime via my email address here or on LinkedIn. You can also find the white paper at the link there, as I mentioned earlier. Thank you so much for this time, and look forward to answering some questions later on.
Thank you very much indeed. That was very useful indeed, very interesting, Kevin. Now, if anything that Kevin said has got you scratching your head and you've got questions for him, please do drop those into the questions tab that you will find in the GoToWebinar control panel. I'll pick those up as quickly as I can, and we'll get to those after we've heard from all the speakers. So now we're going to hop over to my side of the pond, where in the London area, we are joined by Daryl Swanson, who's owner of Swanson Aviation Consultancy. It's a consulting firm focusing on infrastructure requirements for electric aviation and demand modeling. And Daryl has over 20 years of experience as an aviation consultant, working in fields such as airport master planning through to airport acquisition advisory services. He's appeared in some of AIN's Future Flight videos, I'm happy to say, explaining some of these exciting ideas around advanced air mobility. So Darren, please now give us your perspective on how regional air mobility, in your view, amounts to a sound business case.
Great, Charles, thank you very much for that. I'm assuming everybody can hear me. A nod of the head would be helpful, or okay. Right, so I'm Daryl Swanson, independent aviation consultant, a lot of experience in helping people buy airports, and got involved in this game. But I wanted to start to focus on the business models, because I wanted to initially test the Uber claims that this model or this market would exist. So I eventually came up with this distributed aviation theory, and funny enough, it was actually published the same day as the NASA Regional Air Mobility paper. And I think that there's a link that can be shared to that paper. So we go to the next slide, please. So this is really talking about some of the fundamental economics of hydrocarbon versus electric aviation. And I have presented this before, and you can find all this information on my my LinkedIn page. You can find various different versions of it. But in the end, the whole reason why our system concentrates aviation at those 30 airports that Kevin was referring to was just the sheer economics in that these engines are hydrocarbon engines are big because they take a lot of energy to make them work, which makes the engine big, which makes the aircraft big, which makes the airport big. Whereas electric aviation is completely upside down in terms of that model, in that the electric aircraft are smaller, lighter, a lot more efficient, and in the end, there are more small airfields that are closer to passengers' origins and destinations than large airfields with great surface access. Next. Right, so this slide really gets to the heart of it. So on the left, you have a chart there which actually maps out the actual distribution of turboprops and regional jet operations in Europe in 2017, but plots it against the payload and range of those types of aircraft. And what you're seeing is that they're actually peaking at about 200 nautical miles. So it just says that the majority of the airlines that are actually operating those aircraft are really flying them on shorter routes than what the aircraft is able to do. And this just speaks to this whole economics of hydrocarbon aviation. On the right, we're looking at the UK in terms of what some of those aircraft can actually do and the number of frequencies that they could serve just on the existing network at the time back in 2017. So Lilium and Joby could walk in on day one and start competing on a significant proportion of the market without really having to do too much work. Next, please. So this is where it really all came together, and where NASA called it the Regional Air Mobility, or RAM. I was calling it Sub-Regional Aviation, or SRA. I think that RAM wins over SRA in the acronym competition, so Regional Air Mobility it is. But again, this is just focusing in on that chart of previous, where 47% of the frequencies were at about 248 miles. Regional air mobility talks about the 500-mile range. Again, you're getting in somewhere about 90% of the frequencies in the European market. And 1,000 kilometers gets you in about 94, 95% of those frequencies. So it just says that there's a huge market out there where these fixed-wing electric aircraft can operate on a competitive basis. Next, please. Just a quick chart, and we'll quickly go on to the next one. That's just actually showing some of the routes and fares and frequencies. Next, please. Just really pointing out the economic model. And the important thing is that we saw this at multiple different locations around the world in various different countries. So it's not just something that's limited to the UK, it's not something that's limited to the US, but it is a global issue. Next, please. And really, this is a great from the Lufthansa Innovation Hub. It's about that link between fixed-wing electric aircraft there on the right and UAM, urban air mobility, and then trying to get people into that that ultimate access into the city center, where they can either use their Mark 1 feet or public transport or some of the other modes of transport. Next, please. Just a quick slide looking at vertical aerospace. The picture there in the middle is in 2019, services offered in July. So there are only 43 airport pairs with traffic, whereas on the right, there are 286 airport pairs that are in range for the vertical aerospace. So this just speaks about the potential for advanced air mobility. Next, please. And the next slide. Sorry, too many transition slides. So the reason why I've been focusing on the demand modeling side is because you can't take a Morgan Stanley report to some bankers to get some funding for your infrastructure project, or to sell aircraft to somebody, or start up your own UAM airline or eVTOL airline. So the challenge that we have is that we have this wonderful aviation network that has been around for about 100 years. So we have lots of statistics on our hub and spoke system, and where we have traffic, we have great data. But in the distributed aviation system, a lot of that traffic is moving out of some of those hub airports to the smaller airfields that are closer to us. But we haven't got that history of aviation. So we need a new way of actually doing that demand modeling. Next slide. And then we'll go on to the next slide. So we started out with doing the traditional approach to demand modeling. So these are just different screenshots in terms of the study that we did in the UK for the Department for Transport. And this is typical stuff that any competent aviation consultant will be able to kick out for you. And it just talks about where the traffic is, where it's going, what they're flying, what the prices are, and what are the routes, and looking at the actual fare per mile. Next slide. And the next slide. So what we're doing now is we're actually using mobile phone data to actually understand where people are traveling. And it gives us a really good insight into what can actually happen. Sorry, phone call there. So we're getting down into trip volume, travel time, purpose of that travel, the mode of transport, the demographics, and the routes. And if we go on to the next slide. So for this DFT study, we managed to buy some data for 15 potential operating locations in the UK. This is a quick example. We measured the straight line distance, the road and rail distance, and we came up with a simple ratio of dividing that out, and that 0.45 there just talks about the value of advanced air mobility on that route. And the smaller the number, the more value it is. So for the next one. So these 15 different routes, and I've redacted some of that information out. Very sorry about that, but there's some good information in there. It just talks about these various different routes, the driving distance, the time, the travel time, public transport, flight time, and some of the population numbers. Next slide. We applied some stimulation curves. These are well-known aviation stimulation curves that you can apply to it as a first cut, but we get into some stuff that's a bit more interesting. Next slide. And when we start getting into the data, this is the actual information that we're getting out of those 15 different routes. And I think the one in the top right there is actually quite interesting, because that talks about mobility by trip purpose. So we have home to work, work to home, home to other, and then the interesting one, which is work to other, which are really those business type trips, and those are going to be your first users. We can get the mobility by mode of transport. We can get the transport volumes as well. Next slide. So this is what that first cut of the data looks like in terms of the various different city pairs that you have there. And on the right, what you have is the number of daily frequencies that could be happening both ways between those various different pairs for different types of aircraft. So a 4-seat eVTOL, in theory, we base that on 150-mile range, and then we have 6, 9, 12, and 19-seat aircraft. So it just talks about the kind of daily frequencies that you could offer there. And I think the numbers more or less speak for themselves. Next slide. But not to be sitting still, we actually took something called QSI modeling, or Quality Service Index modeling, which is something that we use in aviation for forecasting purposes, and adapted it for advanced air mobility. And it gives us a really good understanding of how much of that modal shift that we could actually get by applying the same methodology and by offering frequencies and different types of services on those routes. So next slide. And these are, again, some of the examples. So what you can really get to is looking at the actual number of people flowing, how much of that market share that you can actually get, and we can actually start to break that down into we can actually start to break that down into the number of frequencies. So on the green on the left, you're seeing the what we were doing with the QSI model, and on the right was the market share. And they're not too bad, not too bad at all. But the chart below there actually talks about the various different sectors and whether it's morning peak or off peak, and the different types of travel. So again, you're really getting very detailed information about this. including directionality, which is very important for scheduling purposes. And that's something else that I'm developing, but we can talk about that later. Next slide, please, and we'll round it off. Again, just some more examples. Next slide. I think we should be coming close to the end because my time is almost up. Oh, and a comparable fare structure. So I'm very sorry about that. It's a bit redacted, but that's probably another story. But by all means, if you're interested in this, please reach out to me on LinkedIn, or you can find me at Twitter under the handle @DarylAviation. So thank you very much.
Thank you very much indeed, Daryl. I do appreciate that. And I noticed that in the questions tab, somebody has very kindly shared a link to the report that Daryl was referring to, in case anybody wants to go over that in more detail. Excellent. And again, if you have any questions for Daryl or anybody else on our panel for that matter, please do drop those questions into the questions tab there, and I will pick those up and get them to the right person. Now we're going to turn to Michael Diamond. He is managing partner of Nexa Advisors, and he and his colleagues are providing strategic advice to those in the regional air mobility front lines, and also in some cases channeling investments into the sector. Prior to Nexa, Michael was Senior Managing Director with PricewaterhouseCoopers, where he was responsible for key aerospace and defense industry clients. And he also served in the business consulting unit of Arthur Andersen, where he was the global managing partner of its aviation industry unit. So, Michael, over to you. We'll be very keen to hear your viewpoint on this part of the industry.
Thank you very much. This has been great to go third because I can soak in the excellent presentations that just occurred and perhaps even comment on those. So we're an investment company. We are in aerospace, very excited about the potential for advanced air mobility or urban air mobility. We are going to be making our initial investments late this year, potentially early next year, in infrastructure. And one of the key points I'd like to make is that it's very important to take advantage of existing infrastructure, like the 5,000 some airports that are available, small airports in and around the United States. I'm actually here in California to speak at an airport conference where the airport community is very excited to learn more about advanced air mobility and how they can take advantage of it. I will, however, say this, that when it comes to use cases like regional air mobility, our view is that going from a vertiport in an urban area to another vertiport in perhaps another urban area, or maybe to a regional or rural airport, is what we think is the killer app for advanced air mobility. And in particular, regional air mobility, as we define it, is where vehicles are going to fly in the range of maybe 150 to 250 miles. And we're not far away from technology and eVTOLs being able to do that. Can you go to the next chart, please? So I've just sort of defined in our viewpoint regional air mobility, but I want to reconfirm that infrastructure for advanced air mobility, which includes really there are two CapEx dimensions to this. One is the ground infrastructure, considering, for example, new heliports or vertiports that are located strategically in mostly in urban areas to be able to conveniently access markets. The other is, of course, the air traffic control aspect and low altitude airspace. Both of those require significant capital investment. And our investors, we look at that investment from the standpoint of where urban areas are in relation to each other, their market size, their potential for revenue, because in order for us to finance infrastructure, we want to make sure that the business case exists to have infrastructure made full use of, so that things like landing fees are sufficient to provide payments to bondholders who are financing this sort of infrastructure. Now, the good news is that urban air mobility or advanced air mobility infrastructure is but a fraction of the cost of other types of infrastructure, including major airports. In fact, the cost to build a brand new, large, very efficient 50 million passenger per year commercial air transport airport in a place like, let's say, the central United States, that cost is higher than the cost of building out vertiports and other AAM type infrastructure within the top 38 or 40 cities of the United States. And the story is different, of course, if you get to other regions of the world. But focusing on the importance of connecting urban centers and providing rural communities easy access to metropolitan areas is one of the fundamental aspects of regional air mobility that we're interested in supporting. Next chart, please. So I think some of you are aware of the fact that we have been relying on analytical tools developed for our investors that look at market opportunity on a city-by-city basis. This graphic on the right is a market forecast for 5 major use cases, and regional air mobility is one of the 5. It's the green bar. Very hard to see the names of the cities, et cetera, but from the standpoint of the viability of advanced air mobility, generally speaking, regional air mobility will likely be one of the early use cases that can be built out, partly through the concepts that have been explained just now by Kevin and Daryl. But the longer haul, more revenue producing RAM opportunity will require that infrastructure be built in and around the urban centers where populations exist and where there are major industrial or financial sector concentrations. Next chart, please. One of the things that we as investors are quite interested in is the what we call affordability index, and we use a financial ratio that looks at forecasted revenue by market area. And what we estimate to be the total cost to build out infrastructure for those. So this is 84 cities. It was too busy to label every dot on this, but some obvious things, obviously, London, New York, Tokyo on the right-hand side are the largest, obviously, from the standpoint of operator revenues. When we talk about London, we don't mean just the city. We also mean the region around London. That would include areas like it would pick up Gatwick, of course, and Stansted, and the industrial, commercial, and residential areas in the Greater London area, for example. So R over I investment has to do with the propensity of an urban center or a metropolitan area to generate revenues that can support the needed infrastructure to create that revenue. And so from our standpoint, any one of the cities that it produces an R over I higher than about 2.75 is, from our standpoint, a potentially good investment. Now, one thing to consider here is, from our viewpoint as well, is whether urban areas are ready for regional or urban air mobility, and many are not. There are some, there are about 20 that we are tracking now, 3 that we're planning to make investments in that score pretty well in terms of our readiness index. And we're probably going to publish a readiness index for 84 cities in the next 30 days. If anybody's interested, email us and we'll make sure that you get a copy of that report. So readiness means basically the city has a formed consortium that might include OEMs, certainly does include existing operators of helicopters or fixed wing aircraft, that there is a capability to deploy infrastructure on the ground. Obviously, this is infrastructure that gets built out. There's no big bang here. It has more to do with phasing in infrastructure and building it out logically, systematically, and of course with the idea in mind of fiscal and financial success and responsibility for that type of investment. So the type of New York will need a couple of $1 billion, for example, of infrastructure, but the city has the potential to produce as much as $20 billion in revenue from these use cases. So there's plenty of R over I to make use of this ratio. I hope that's helpful to people. Next chart, please. So one of the things that we've just completed was an analysis of the state of Ohio. We did this for ODOT, the Ohio Department of Transportation, to look at the viability of investment in ground infrastructure for the state, and concluded many things. This report is publicly available. I encourage people to get a copy of it. You see on the map here cargo logistics corridors and many other features that are relevant to planning regional air mobility and other aspects. So I think there are close to 90 airports, small airports, just in the state of Ohio, many of which can be used to facilitate regional air mobility quickly. The good news here is that the state is working on legislation now to provide public monies to do things like transportation studies, to help seed public-private partnerships for the deployment of infrastructure. And this needs to be done in partnership with OEMs on the consortium side that are capable of delivering vehicles and making use of new infrastructure as well as existing infrastructure to close the business case, basically. So we as investors are quite interested in how the business case will be coming together. There's no big bang here. This is a lot about how cities can embrace, encourage, and provide the concessions for operators to come in and begin providing these services. And it's to us, we're very excited as our investors to be considering, and we encourage those of you who have projects that are potentially ready for capital finance to come to us and talk. Next slide, please. So this is just an example of the Ohio's 9 commercial airports, and there are actually about 500 small airports and even heliports that exist in the state of Ohio. So naturally, one would want to take advantage of that infrastructure because it's all paid for. But the densification of Ohio will be very important. Last slide, please. So one of the things that we looked carefully at was regional air mobility from the major Ohio cities. This chart identifies 6 connections between Cleveland and other cities of economic importance to the city of Cleveland. Of course, every city has its own story, but the revenues for regional air mobility we estimate are at around $4 billion, which is more than sufficient to support initial investment in further infrastructure, including the need for a selected number of vertiports within the core areas of these cities. Neither Cincinnati, Columbus, nor Cleveland have publicly available vertiports today in the urban core of those cities. And that obviously is one of those areas that is where investment can occur fairly quickly, and likely in partnership with the state and a P3 that would come together and be able to support regional air mobility activities. I think that's my last chart. So thank you very much. Looking forward to talking the financial aspects of RAM. Charles?
Thank you very much indeed, Michael. And let's make the best possible use we can of the time we have for questions. We can dig a little deeper here. I can see some questions coming in, so I'll jump right into those. Michael, since we've still got you on the screen, somebody is asking, does Nexa invest only in infrastructure and or also in the actual new air vehicles themselves? And let me add a follow-up to that. When it comes to investing in new aircraft programs, do you feel that maybe we've seen most of the large-scale investment in this sector already, partly through mergers with special purpose acquisition companies, or do you think there are yet more big bucks to keep flowing into these new aircraft startups?
Right, so we're an investment bank, and we focus on aerospace. We've been involved in 2 of the major SPAC transactions that have occurred this past 12 months. And we estimate about $10 billion has come into vehicle development programs. This includes those widely published, like the Joby Reinvent Capital transaction, but also investments being made by larger corporations, Bell, Boeing, et cetera. So that's a significant amount of money. We think that that investment will probably double over the next maybe 12 to 18 months. We are aware of a number of other SPAC transactions and it's not just vehicles. There's if you look at Blade, you know, they're intending to build out operating networks and to acquire vehicles, put them into service. There's a significant amount of money that is likely to come into that sector. There are 4 supply chains. There's my fingers. 4 supply chains that have to be considered in order for cities and metropolitan areas to become viable from the standpoint of you know, this sort of opportunity. So we're going to see some very interesting results.
Very good. Thank you, Michael. Kevin, I'd like to get back to you, if I may. Of course, X-Wing, as I understand it, your primary focus is on introducing autonomous flight technology to operate aircraft autonomously. But do you as a company also have an interest in the new propulsion systems, in changing out existing propulsion systems? And even if you're not, I mean, do you have a view on whether existing electric battery technology is sufficient for the sort of range needed to support the regional air mobility missions that you've described, or is hybrid electric the first necessary step?
Yeah, so I can't, as I mentioned, I've been at X-Wing for about a week, so don't have too much information on that front. But yeah, as far as the white paper is concerned, we did talk through essentially a pathway for electrifying RAM, and you're already seeing it with the likes of Ampere and others that are taking existing aircraft. And I think today they just announced Surf Air Mobility that they are likely to purchase 150 if they get the funding for a couple of caravans from Textron. So you're seeing that as kind of the initial step of retrofitting existing aircraft with these new electrified powertrains. And so, yeah, I think hybrid makes a lot of sense currently. But I think the real benefit long term is transitioning fully to electric.
Very good. Good answer. Daryl, let's take this one to you, if we may. So somebody actually asked in follow-up to Michael's presentation about the work he's doing in Ohio. And the question was, well, in places like that, is it likely to be the state authorities themselves who are running these regional air mobility services, or indeed in Florida? Of course, you've looked at several different communities. Do you see all these services being operated by private airlines, private commercial air operators, or could there be a sort of public-private partnership in some places to get those started?
I think the appropriate phrase there is IDIC, infinite diversity and infinite combinations. The U.S. model of airport ownership is very different from, say, that in the UK or in the rest of Europe, where you have governments investing in that infrastructure and you have the bond system to fund that. They have tried the PPP route on some of their airports just even a few years ago. They were moving down that route, but they haven't been very successful. I do see the PPP route as something that could happen in the US market. I think in Europe, in the UK in particular, it's probably going to come down to private investors investing in the infrastructure. As for the operators, again, I would expect private companies to go into that space. I would be very hesitant to recommend public funding for any of this. I think it needs to stand on its own without access to public funding. I think public funding can possibly fund some services where you have, say, a specific need for an additional flight, and we have those public service obligation flights, and that's where public funds should come in.
Yeah, good point. Let me just ask a quick follow-up, and I'll throw this same one over to the other gents that we've got. You know, in the old days of regional aviation, it would have been good old-fashioned airlines, including some of the major airlines operating on these routes. And of course, what we saw historically was major airlines trying to get out of that business because they just didn't find it that attractive. More recently, we've seen major airlines like United and American actually committing to investments, certainly in the eVTOL sector. So would you expect to see major airlines trying to get back into this space, Daryl?
Funny enough, I predicted it several years ago. It just made sense to me. And I was actually thinking it would be and Emirates would be the first mover, or Virgin. Of course, Virgin are moving into it, and you can see them possibly trying to offer some kind of an eVTOL service for their first-class passengers. But the trend that I'm actually seeing is that they're looking to get into those markets to set up specific carriers for doing various different routes. Of course, they can use it to feed their traffic, feed their hub and spoke system. But I wouldn't be surprised if there's an adventurous airport out there that would look to develop a type of feeder service for their own operations to feed their existing airlines to bolster that business. And that's when it gets interesting. And that's where I'm starting to see the potential development of what I'm calling sub-regional hubs. So passengers will naturally start to hub through some of these smaller regional airports where you have good connectivity. And we're already seeing that with the low-cost carrier sector. There are airports around the world that set up specific services to allow people to self-hub on the low-cost model.
Very good. We're running out of time, so I'm going to move quickly. Michael, do you have any sort of follow-up view on whether we think airlines are going to get into this regional air mobility space, or is it all going to be sort of newcomers and startups dominating this?
Yeah, well, I think both. I think that the airlines are going to focus on their high mileage travelers and be able to do the door-to-door thing. One aspect that's important from an infrastructure standpoint is that the major airports themselves, if we are going to connect the odd business traveler from, let's say they're flying in from a parking lot next to their high-rise building to the airport, we will need a special terminal at most of these airports to be able to ingress passengers and handle higher volume eVTOL traffic. So that's a significant investment. Our average estimates, I think, are around 40 million US per airport, although that number does change depending on the country and so forth. So I think from that standpoint, the airliners are going to get into this in a fairly sizable way. And I also believe very strongly that Daryl and Kevin's vision is also going to come true. So you'll have, I think, it's not a dichotomy. It's really kind of a synergy where mobility is going to improve, and there are really 2 or 3 different but very exciting business models. They all need infrastructure, which makes us happy. But I think it's very promising looking at both sides.
Good. I'm going to carry on until Jolanta tells me to shut up, which I suspect won't be too far away now. Kevin, just very quickly, some of these new aircraft that we're talking about as being contenders for regional air mobility, they're pretty small. They don't have that many seats. In some cases, maybe just 8 or 9 seats. Now, in the old business model, that wouldn't have seemed anything like big enough to be worthwhile. What's happening here? Is it simply that, you know, the model has to make the best use of the available technology, and if current propulsion can only support 8 seats, fine, we'll get the best out of that and wait for something better to come along? Or is that sort of the sweet spot to have these smaller aircraft with fairly small capacity?
Yeah, so I think, Daryl mentioned it a bit. Demand is always difficult to guesstimate at this point when you don't have existing operations to play off of. And I think, to the earlier question, I mean, there's companies like Cape Air, Southern Airways Express, Blade that are already starting to form these partnerships with airlines, et cetera, that we can just continue to build off of, as well as Mokulele Airlines out in Hawaii. But sorry, back to your original question. There is yeah, I think there's definitely a market for what used to be called thin haul travel, where you've got very small communities that still need cargo, that still need passenger transportation, that still need very easy, accessible options for these kind of distances. And so I think there definitely is a significant opportunity to look at more distributed aviation, where you're not putting 70% of all domestic travel into these 30 airports, but actually using the full scope of infrastructure that we have. And I think 19 seats, 30 seats, these kind of, depending on the demand and the city pair, it can definitely make sense.
Very good, thank you. Yolanka is winking at me. I think we're out of time, aren't we, Yolanka?
We are. I want to thank this panel, Michael, Kevin, and Daryl. Thank you for your presentations. Charles, as always, thank you for a wonderful job of moderating. And we have actually reached our break time. So we are going to take a 30-minute break, or maybe 28-minute break. That will put us back here at 1:40. If you're on the East Coast, you can grab some lunch. Here on the West Coast, it'll be 10:40, and I'll grab some coffee. And Daryl, it's probably dinner time, if not time for a gin and tonic for you. So thank you all, the webinar page will remain live, and we will see you back here at 20 minutes to the hour. Welcome back to the second half of the first day of the Electric Aircraft Symposium. We got off to a great start this morning with two panel presentations on a global industry overview and regional air mobility business case, and we are now going to transition over to another great panel, this time on aircraft conversions and supplemental type certificates. And I will introduce your moderator and then let him introduce his panelists. So your moderator is Ken Schwartz, who is a senior marketing and communications strategist with Aeromedia Communications, where he works with clients across the helicopter, vertical takeoff and landing, and commercial aviation sector. He also serves on the board of directors of the Vertical Flight Society and is the director of marketing communications for this Electric Aircraft Symposium. Ken, it is all yours.
Thank you, Yolanka, for the introduction. Today's panel, Aircraft Conversions and Supplemental Type Certifications, closely follows on the themes of the two earlier panels today focused on aircraft development and market opportunities. Next slide. And next slide. First, I'd like to provide some context. It's the aspiration of every aircraft engine manufacturer to displace incumbent engines on existing aircraft and inspire new aircraft designs. Hang on a sec. There's a long history in the aviation industry of companies introducing new propulsion technology on fixed-wing aircraft and rotary-wing aircraft by way of a supplemental type certificate. These programs have been initiated by original aircraft manufacturers, engine makers, third-party conversion companies, and even by end users. Piston to turbine engine conversions, which really began in the late 50s, early 60s with new engine availability, resulted in higher acquisition and operating costs than the piston engines they replaced, but provided a number of benefits, including improved performance, be it speed, payload, climb, hot and high performance or cold weather, often associated with the replacement of a heavy piston engine with a lighter turbine engine. They increased reliability, and they extended the product life cycle of an aircraft and provided ongoing product support opportunities. Next slide. Next slide. Next slide. In the skies overhead, these STC conversions have provided a segment of the air transport fleet. It includes early on the Convair 580, which was a re-engineering of with an Allison engine. Next slide. It included numerous agricultural aircraft that replaced round engines with Garrett or Pratt & Whitney or Walter engines. Next slide. It included utility aircraft like the Basler BT-67, which is a refreshed Douglas DC-3. Next slide. It included the Turbo Otter by Vaisar, which replaced a round engine with a turbine engine, increasing the speed and payload of this aircraft. Next slide. It included the Sikorsky S-58, which had a Pratt & Whitney twin pack. Next slide. Next slide. Next slide. Next slide. And more recently, you have the Eagle Copters 407 HP, where they replaced the Allison or Rolls-Royce engine with a Honeywell engine. Next slide. Today, we have a new generation of entrepreneurs driving the conversion market. We're at a tipping point. While most of the market investment is focused almost entirely on eVTOL aircraft yet to be certified, there's a tremendous opportunity to retrofit existing aircraft with electric technology. It's a winning business case. 3 announcements in the past few days highlight this fact. Last week, Pratt & Whitney and de Havilland Canada announced collaboration on hybrid electric technology demonstrator of the Dash 8, securing Canadian and Quebec government support. And just today, Surf Air Mobility committed to buying 150 Cessna Caravan EXs and converting them to Ampere hybrid electric propulsion systems. Our 3 panelists today are well known for their work electrifying popular general aviation aircraft with battery electric and hybrid electric technology. As pioneers and forward thinkers, their vision and talent extends beyond the aircraft they're currently working on to a whole family. Okay, our first speaker today, next slide. Actually, our first speaker today is Lee Human. He is president and CEO of Aerotech, which provides flight test services, certification, and engineering services. Lee's forward thinking has led Aerotech to focus on the product development and certification of emerging aerospace technologies, supporting customers who are developing electric, supersonic, and eVTOL aircraft. Over to you, Lee.
Hey, good afternoon, everyone. Really pleased to be part of the panel today. It's certainly, this activity is really close to my heart to move aerospace forward in this way. Next slide, please. So some of you may recall that we've flown the fully electric Cessna Caravan out of our flight test center in Moses Lake, Washington recently. And I thought this would be a good time to kind of maybe dig a little bit deeper into how we did it for the benefit of those that are, as Ken said, re-engineering is not particularly new, but there are some new things when it comes to electrifying. And I'm going to kind of share some of the more engineering background on what we did. Next slide, please. So first and foremost, yeah, we're experts in legacy aircraft STCs. We've done a lot of certification activity, but when it comes to electric, I guess I'll just summarize by saying we knew that we didn't know a lot. So we knew we had a journey of discovery and learning ahead, and that certainly came true. So anyway, a quick video to kind of showcase a 30-second video on the aircraft itself. So if you wouldn't mind, please playing that video. So this is the first flight of the Caravan out of our flight test center in Moses Lake. It is a full electric machine. So we had large battery packs in the main cabin, and we had a Magni-X propulsion system in the front end and their controllers, as well as EP systems, battery packs, and of course Aerotech did all of the engineering integration, all of the safety analysis, and ultimately demonstrated the capability. So huge, I think that was a huge milestone for electric aviation. And frankly, I'm going to go through some of these lessons learned and what we can share here today. So next slide, please. So again, just the basis. So obviously a collaboration with Magni-X that is providing electric propulsion systems. Our aircraft, one of our flight test aircraft, and then based out of our test center in Moses Lake. We actually got approval to launch in March of 2019, and then went from zero to first flight in a little over a year, which for those of us in the industry, that's pretty good. That's pretty impressive, I think, especially adopting a lot of these new technologies, going from all the way through the design process, manufacturing, ground testing, all the way through first flight. And we finished our work about this time last year, actually. Next slide. So let's dig a little deeper as to what it takes to do this. It starts with all of the safety. You've got to evaluate all the safety considerations with the systems, right? We're not touching the flight controls, we're not touching the basic OML of the aircraft, but we certainly are touching, again, all the propulsion systems, engine indication, engine control, many other cooling systems, etc. So when we do this, we have to go deep dive into the failure modes and effects. We have to look at the safety and make sure we've got a strong foundation, that we understand what the reliability of all of these subsystems needs to be, so that we have a certifiable result. So we did that. Exhaustive safety analysis. We identified 37 particular conditions that could result in hazardous or catastrophic, which then helps guide you to the design as to what you may need with system redundancy, system reliability, and then showing that your system design addresses those safety issues. So we came out with 14 what we call derived requirements out of that work, which really helped the design team get through and again, as demonstrated by the flight, give us a flight-worthy configuration right away. Next slide. Some other things that we learned along the way, a substantial one which should not be underestimated is the human factors issue here. For those of us that have flown, regular Caravans or regular King Airs or other aircraft, we have assumptions, and we don't even realize how much we assume when it comes to operating aircraft, like starting an engine and taxi and these other activities that everyone is just used to. This is very, very different when you look at an electric aircraft. The pilot interaction, the normal procedures, the emergency procedures is brand new territory. How you start is brand new territory. How you fuel. So that was a major area. I'll just say it's new territory that I know all the panelists here have had that journey, and we're in the process of standardizing some of these things. I'll just also add that we should not underestimate the level of effort required to address engine propulsion system control and propulsion system indication. And going from a legacy cockpit to a electric aircraft cockpit is substantial. And the good news is we're seeing avionics companies leaning forward, recognizing the market, and actually starting to develop and certify, I'll say, e-propulsion ready avionics packages. EMI, obviously, we all knew that we were going to have EMI issues. You can't have a megawatt of power without some EMI. But even that, it's in some respects we underestimated the challenges. So making sure, you've got good laboratory testing, good bench testing to characterize the equipment as you go to the aircraft. We did have some redesign in terms of shielding and separation. We got through it, but again, we were caught up with the challenges in some of the EMI activities. We did not address in this project. We did not yet address lightning protection and HERF. We know what that looks like, but just for clarification, this aircraft, we were able to put restrictions on the aircraft with respect to operating conditions to do what we did. Next slide, please. So the easy part, installing the motor, what frankly was the easiest part of this activity. Aircraft structural design is aircraft structural design. So while my structures engineers would take offense to that comment, frankly, that was the easy part. Next slide. And I guess the good news there is, it's easy to adapt. The Caravan's a great platform. A flying tractor in some respects was easy to adapt. Where things got tricky is in cooling. I think we all respect the amount of energy that it takes to fly an aircraft, whether it's a PT6 that's putting out 800 plus shaft horsepower, or these electric motors that are doing the same. There's a lot of energy and there's a lot of heat byproduct from that, both from the motor itself, but also all of the high power electronics, which have to be cooled. We knew it was a challenge going in, but I'll just say it was probably one of the biggest challenges technically on the program, because we're packing in not only the primary propulsion system, but a lot of, I'll say, life support systems, propeller governor, oil supply, the cooling systems, the classic 28 volt DC power for legacy radios and lights and beacons, etc. So quite a lot to go handle there. That was a challenge. The other thing I want to point out is, and Ken hinted at this when it comes to reliability, was some of the redundancy and fault tolerance that we put in the airplane. I do want to acknowledge that electric propulsion systems in general are incredibly fault tolerant, more so, and this is really this is good news, more so than a classic piston engine or turbine engine. And I'll especially when we get to these larger scale motors, they're typically stacked up multiple motor systems with multiple controllers, and which is great from a safety perspective and a reliability perspective. So we need to start thinking about some of these installations as effectively multi-engine installations, because they are truly multiple motors on a common shaft with multiple sources of power. So something just to think about. It's new in the failure modes and effects, and it helps, I think, a lot for these kinds of aircraft. The other thing, I think, big lesson learned on our part was we had a common cooling system for the motor and the controllers. We might do it differently next time. We might do separate loops for the control and for the motors themselves, just because they're very different in their cooling needs. And we tried to have a generic system. And I guess for those engineers out there trying to work through this challenge, it's the delta temperatures across the heat exchangers provided some challenges for us in terms of having one loop that did it all. So that's just something to share. Next slide. I mentioned subsystems and life support. There's a lot as you remove the PT6 and you start looking at replacing those functions and specifically cooling. I'll just summarize by saying don't underestimate the challenges of this, and then frankly how many parts need to go on the front end of that airplane to make this work and for it to be certifiable and safe. Next slide. Other considerations that I know many of you that are listening have already learned, but to state the obvious, we've now introduced 700, 800 plus volt high voltage systems into a world that is not used to that kind of electrical power. That requires special high voltage training for technicians. right? We can't just let any A&P mechanic start installing electrical power systems. You have to go through high voltage training and have the correct safety equipment. So that was we sent quite a few people to training. We hired some specialty companies to come and help us with that. So it's just something to make sure you're aware of. In general, from a flight test perspective, we had a lot of new risks to assess and new procedures to develop to fly the aircraft. Silly one, but this engine can come to life at any time. It's not like a PT6 where you have advanced warning of the engine starting. You can hear the igniters, the propeller starts to spin slowly. Electric motors can come to life as soon as they have electrons, and that's milliseconds. So a lot of things to think about with respect to test safety and procedures. And then I already hinted a little bit around the starting and taxi and emergency procedures. We wrote a new flight manual, of course, for the aircraft with new procedures, and we learned a lot in that process as to what can be the same, but then what needs to change. And that'll be obviously something that we're presenting to the FAA as we go forward. So just in summary, look, this is not a PT6. This is a new propulsion system with a lot of new things to go consider. Next slide. So the good news is lots of good news here. Number one, the FAA is ready. I think a lot of us here are aware we have the new regulatory framework with Amendment 64 for Part 23, which has really opened up the door for innovation. And not only do we have that, but we have a team within the FAA that's focused in having some early conversations and helping applicants get through the certification process. We've seen recent evidence of special conditions being published for some of these new propulsion systems, like the Magni-X system, which is great. And also we've seen that there's multiple certification paths for applicants. Go the classic Part 33 route. You can now integrate these systems into the Part 23 cert. So really, and of course, there's the TSO process. So it really is all of I'll say the pieces of the puzzle to enable certification are firmly in place, and the FAA is providing great support. Next. And just as a reminder, some of the, I'm not going to deep dive this, but the Amendment 64, the new Part 23 process goes from the old system, which is shown graphically on the left, where it's basically a weight class and propulsion class system, to now more passenger-based and speed-based system, which helps simplify a lot of these projects. But more importantly, gets rid of the 12,500 pound rule. So now we can have an airplane that is over 12.5 and still within this category. Next. Next slide. So what's coming? Number one, I think we all see great progress across the industry, right? We're seeing propulsion systems going through the final certification process. As I mentioned before, we're starting to be aware that avionics suppliers are designing and getting equipment ready for this market. And then we're seeing energy subsystems components now going from what might have been an automotive grade, which is really not suitable for cert. And now there are subsystem products coming forward to allow us to integrate this and get this all certified. The other key element here that shouldn't be underestimated is this is an electric propulsion system that can be powered by electrons from any flavor. It could be battery system, like we used. Could be hydrogen fuel cell. We've seen the teams at Universal Hydrogen developing some incredible technology. It could be hybrid. It could be a gas, like a mini. Think of it as a mini APU that's providing an electrical power source, which is a very interesting solution. Bottom line, we've learned a lot through this process. We're now in the final stages of getting the right pieces together to move the Caravan project forward. And we're happy to say that we've updated all of our processes, tools, and procedures, and we're ready. So we're ready to do this final work and help industry get an electric Caravan in the air.
Very good. Thank you very much, Lee. I would like to remind everyone that we're taking questions in the question sidebar in GoToMeeting. Please put your questions in there. At the end of the session, we will be going through the questions. Our time is tight, so I want to get on to the next speaker, which is Kevin Nokier. He is the co-founder and CEO of Ampere and the founder and president of the AMP division of Surf Air Mobility. Over the past half-decade, Kevin and his team have pioneered practical, compelling, electrified flight through the upgrade of existing aircraft types. He's also a newsmaker. Kevin, over to you.
Thanks for the intro. Thanks for the for setting the stage here, Ken, and Lee. Thanks for a really interesting presentation. You know, I'm leading on from where Lee left off. Want to take a few minutes here to talk about Ampere and some of the projects that we've had, some of the applications of all of those, the systems engineering, requirements work, integration and test work that Lee described. We've had some opportunity within Ampere to experience that a few times in our flight test programs and certainly in our product development activities. So if we could actually start with that electric eel video, then I'll jump into charts thereafter. This program is a world's first. The chain of islands here in Hawaii offer a unique transportation challenge where travel is necessary for short distances. At Ampere, one of the key words in our mission is being trusted, the trusted developer of practical, compelling electric planes. This program couldn't have been possible without Elemental Accelerator, Mokulele Airlines, and Southern Airways, who are actually shifting the structure of the industry from large planes down into these smaller regional planes, which ultimately are also more sustainable.
These test flights are really the culmination of hundreds and hundreds, not thousands and thousands, of hours that people have put in to make this happen. The hangars have been rewired, the new power supply is there, and we're ready to go.
So in that video, you heard us talking about a few different elements of when you really deploy these aircraft. Some of the things that we learn are beyond just the airplane. We're looking at the infrastructure, the airline operations, the different types of support systems and networks within the ecosystem of aviation that really need to come together. If we go on to the next slide. So as you can tell at Ampere, and for those who aren't familiar, we're upgrading existing airplanes with electric vehicle technologies. We're actually starting with hybrid electric systems. We architect, design, and test those systems. We leverage the existing supply chain and help promote the growth within the supply chain of key subsystems, whether those are in the motors, batteries, generators, or power electronics. We do a significant amount of the analysis, documentation, and process, much similar to what Lee described that Aerotech works, but we also work with companies like Aerotech who bring expertise in that certification system and process, and have actually moved down the re-engineering path with more traditional technologies, and now applying that approach to the electrification systems. So next slide. One of the things that we focus on at Ampere is to build a technology base, a platform of technology, which is resilient to tech change over time. So consider, for example, improved energy storage systems, but that is also flexible and scalable to multiple platform types. So that the core components, let's say a battery module or a control system, will be applicable not just into one STC, but we are looking at going at multiple supplemental type certificates and products in market eventually. One of the keys that you've heard that is enabled by going through this aircraft upgrade approach is that we're able to comply with the existing regulation, use existing infrastructure, and that we're actually able to use the trusted aircraft that are already in operation within this industry. So next slide. So we've got kind of a three-step approach where we've been over the past years been working to upgrade those aircraft. You saw the video of our electric eel, that's an upgraded Cessna Skymaster. The next step for our company, which is there in the center, about partnering with OEMs, though it says tomorrow, that step in our history actually began today with a big announcement that we made alongside Textron. And this is about taking that technology which we've developed, integrating it into multiple aircraft types, and then working with those OEMs along the STC process, but of course with the intention of getting fresh built off the factory line planes with hybrid electric systems one day. And all of this is laying a foundation for the wonderful and exciting future that we all believe in, which is clean sheet designed vehicles that are able to fully leverage the technology. So over the next slides, I'm going to just touch on a few of the different applications and share a few stories within the time that I have here on the activities that we've pursued. So next. The first plane that we flew early in 2019 in summer 2019 was an upgraded Cessna Skymaster. Now in the first iteration of that plane, we had the combustion engine in the nose, the fully electric system in the tail, battery pack stored in the cabin, much like the Caravan that Lee's team did. And that was, simplicity of integration, really first time learning through. For the second iteration of the Skymaster upgrade, we actually switched the location of the combustion engine versus the electric. So electric up in the nose and combustion out in the tail. This was partially done because we wanted to work through the weight and balance of the plane and actually open up the cabin so that we could fly passengers in those seats. Because we're looking at commercial products and we're always trying to drive toward a more, I'll say, realistic commercial integration. That was a really important learning exercise for us to get that front-facing propeller. Under the aircraft here, you can see we moved the battery packs out of the cabin and into an aeroshell, a belly pod, which contains those and separates them from the fuselage. And learned a whole lot during these programs. If you go to the next slide, during our flight test program here in California, we had a very long flight on our hybrid electric system. So 341 miles, took about 2.5 hours. That was a repositioning flight between Southern California and Northern California. A large number of flights over the course of about a month here in California with high dispatch reliability in this phase of the program. And then if you go to the next slide. We deployed the plane out to Hawaii, and so this is taking all that we learned about the electrification systems and now starting to put it into customer hands. So one of the voices that you heard on the video at the beginning of this presentation was the CEO of Southern Airways and Mokulele Airlines, and Stan was one of our really key partners in understanding what are the operational requirements of these systems. It's not about doing science projects, it's about doing engineering that leads to practical and compelling products. And so last December, we deployed our plane out onto one of the essential air service routes. So this was an experimental market survey category, which was a first of its type approval for those operations. Flew multiple times per day, so daily routes, just like the EAS routes would be flown, and really gained a lot of insight into the reliability of the system, as well as the infrastructure that's required for those daily ops. Next slide. So the next step for that vehicle is to be shipped off to the UK. So it actually just arrived in the UK just a few days ago, and is part of the UK Future Flight Challenge. So an investment that the UK government is making into bringing sustainable aviation to that region and really building out the full ecosystem of support. So what we've seen in our approach, and what we believe is at the core of this this approach to upgrade planes, is about being rapid, about being able to open up the market, also being able to familiarize people and communities about what electrification can offer. While flying in the UK, we'll be up in the Orkney Islands in Scotland, but then also down in the southwest of England as well. Next slide. So we took all the learnings that we gained from the Skymaster upgrades and used really the systems engineering, the requirements, and the supply chain that we have developed, and have been doing studies on a much larger aircraft. So this is the Twin Otter DHC-6, 19-passenger plane, also used for cargo, and have been studying in partnership with NASA what it would look like to electrify this plane, again, a hybrid electric configuration, and ultimately looking toward bringing that product to market as an STC. And then next slide. And last that I'll mention on this call today, we did announce some pretty big news earlier today, very exciting for all of us, that Surf Air Mobility and Amp Air as a division within Surf Air Mobility has a collaboration with Textron Aviation, an exclusive relationship to electrify the Cessna Grand Caravan. And what we see is one of the most prolific aircraft in this industry, used by most of the customers who operate in the space. And we'll be able to bring a really, really compelling product to market in the 2024 timeframe, and specifically looking at hybrid electric variant of the Caravan, where we're able to be kind of like a Prius, where you don't have to have the charging infrastructure at every airport you land at. You're able to do some in-flight charging. You're able to operate more efficiently than the combustion aircraft was. So a few specific numbers. In the Skymaster that we were flying in Hawaii, we demonstrated an over 30% fuel savings in that hybrid configuration, and here our target is on the order of 25% fuel savings for the hybrid electric Caravan. So with that, I'll hand it back to the moderator and look forward to the Q&A.
Thank you very much, Kevin, and certainly exciting news for your company. Our session today will end at 14:35, so we're off. We have a hard stop. There's another session that will follow closely behind us. So again, if you have questions, please put them into the question box, and I'm going to welcome our next speaker. Glenn Drumgold is the founder of Tier 1 Engineering, an innovative design and development company serving the aviation industry. In 2015, Glenn led the development of the world's largest battery-powered helicopter, which makes Glenn certainly a pioneer. Glenn has 20 years of experience in design and development of commercial and military aircraft. Over to you, Glenn.
Good morning. Thank you very much for the presentations, and thank you for leaving me something to talk about. I'll try and keep us on schedule and work quickly through the presentation. So Tier 1 Engineering is developing the electric R44 helicopter. It's known as the ER44, and I'll talk a little bit about the development work we're doing there, and then I'll talk a little bit about STC certification, just in general. So if we can move to the next slide. This is showing the early development work that we did. We took a 4-seater Robinson R44 helicopter and replaced the Lycoming IO540 engine. It's depicted here in the schematic on the left-hand side. We left the drivetrain intact. So basically, it's just an engine replacement. Operationally, the aircraft does not change considerably. The systems remain the same. The safety features remain the same. It can still auto rotate, has a sprag clutch installed, and so to a pilot, the flying characteristics have not changed at all. On the upper right-hand side, you can see the Lycoming engine. It's a very large engine. It's 500 pounds in weight, and it takes up most of the engine bay. And on the image below shows the propulsion system. This is actually a twin engine propulsion system, and it's considerably smaller, and the weight is on the order of 100 pounds. So it's quite a considerable change in weight of the electric system. So that was our proof of concept. It utilized mostly commercial off-the-shelf technology borrowed from the automotive sector. At the time, this is going back 3 or 4 years ago, there were very few products in the aviation world for electric propulsion. So this was cobbled together. The project took roughly 9 months of development. The batteries are not shown in the image to the bottom right, but the batteries were supported under the fuselage. There are photos on the internet. I think Vertical Flight Society has done some presentations. So if you want to find out more, you can have a look at their presentations on that. Next slide. So this is back in 2016, just some of the progress we made. The first flight was 5 minutes at 400 feet. And then we slowly increased it up to 30 minutes. And in 2018, we accomplished a world record. And this is a photo of us receiving the award. Martine Rothblatt is standing next to me on the left. And she's the sponsor of the project. And to the right of her, to the right in the photo is Rick Webb. He's our test pilot. Okay, next photo or image. So why do we modify an electric R-44 helicopter? It's a good question. A lot of people think helicopters are not suited to electric propulsion. They didn't think it was possible. And well, it turns out that it is. And it's actually a very good candidate for electric flight. The aircraft has great utility, and it's the most produced general aviation aircraft in the world. There's over 7,000 of them built. They're readily available. They can be serviced worldwide. So there's an infrastructure for servicing the aircraft in place, and there's minimal pilot training required to change from regular OEM piston-powered operation to electric propulsion. So we thought they were all good reasons for adopting the R-44 helicopter. Another reason is at 2,200 hours, the aircraft needs to be overhauled. The Lycoming engine requires an overhaul. So we thought that was a good opportunity for operators to do the conversion should they choose to do so. Number 3, another benefit of doing a conversion as opposed to a brand new clean sheet design is you don't need to type certify the airframe. So it's a supplemental type certificate, just dealing with a modification of that aircraft alone. So we don't need to certify the airframe to today's rules, which are always tougher than yesterday's. So it allowed us to focus on the novel technology, which is electric propulsion. The airframe for the R-44 has a very low empty weight fraction, so it's very efficient structurally. And I doubt there would be many aircraft in the world today that have a lower empty weight fraction, which is very important for electric flight because, as we know, the batteries are not anywhere close to the energy density of fuel. So any efficiencies we can get structurally or in the propulsion systems help us in terms of range of the aircraft. And number 5, the R-44 has very low disk loading. So that gives it good propulsive efficiency and relatively low noise. Next slide. So the evolution of the aircraft, this is a photo of the second, what we call Bird 2. It's our second version. This was developed entirely in-house, the systems were, and we're currently entering operation of this aircraft in terms of flight development testing. The aircraft will be, there'll be a lot more in the news in the coming months as we embark on some of our flight tests and look to the Vertical Flight Society for photos and documentation on the performance and the design of this particular model that we're working on. Okay, we can go forward. So I wanted to talk a little bit about design and certification. So the design process starts with understanding the requirements. So to understand requirements or to develop requirements for the design of an electric aircraft, we really need to understand the safety aspects, because safety is a large proportion, makes up a large proportion of these requirements. And a good place to look for guidance is the regulations. So the question is, do the current regulatory rules work for electric propulsion? They were developed for piston engines, they were developed for turbine engines. So the answer is yes, but only partially. So in our application, we have two guiding standards. One's Part 33, which covers the engine itself, and the other is Part 27, that covers the rotorcraft or the installation of the engine. So for those two regulations really, or the applicability of those two regulations really depend on the architecture of the aircraft. So the current standing with the FAA is for electric engines that are installed in federated system architectures, that's architectures where the engine's clearly separated from the rest of the aircraft systems. The FAA may require two separate type certificates. So one would be for the engine and the other would be for the STC, for the installation of it. And this differs for maybe like a quadcopter where the engine's highly integrated within the airframe and is really part of the stability and control system for the aircraft. So if that was the case, there's unlikely to be a requirement for a Part 33 engine certification. It would be purely Part 23 or Part 25 for that type of system architecture. So how do we deal with the rules when they only partially address electric propulsion? So what's happened is industry committees have been established. There's currently three main ones: the ASTM standards, the GAMA committees, that's the General Aviation Manufacturers Association, and the SAE committees, in particular the E40 Electrified Propulsion Committee. And that's a very active committee, and I'd encourage anyone embarking on a design of an electric propulsion system for an aircraft to participate in that committee. So those committees are there to interpret the airworthiness standards and develop consensus standards that are specifically for electric propulsion systems. So I've listed two consensus standards here that have been developed, and they're very useful for designers of electric propulsion aircraft. So there's 3338 covers the EPU, or the electric propulsion unit, and 3235 covers the battery systems. So those standards are helpful for establishing your design requirements. Where there are gaps in the regulations, and maybe the regulations don't address specifically aspects of electric propulsion, the FAA uses special conditions. And an example of a special condition for electric propulsion was issued in November, quite recently, November of last year, and it's for the Magni 250 and the Magni 500 model engines. So that's a proposed rule. It's not a rule at this point, but that's a special condition that addresses some of the gaps in the regulations. So when if you're developing a system, you've got the standard consensus standards, you've got the regulations and the special conditions, and they can all be used to develop your requirements. Once you open a project with the FAA, there's also a lot of dialogue, a lot of applicant meetings to ensure that you have a viable path to compliance. So in terms of design, you have your requirements is a good source of information for requirements. The rules are in place, and there's a lot of FAA support at this point. Next slide. So here's the challenge. You've got your regulation, you've got your requirements. Now you need to design and validate the system. So we need to understand what's known as the means of compliance. How do we comply with these rules? And what I've done, I've listed what I consider the three main rules for our program, and they will apply to many other electric propulsion programs. The first one is, how do we ensure continued safe flight and landing after a single electrical fault? And you heard Kevin talk about some of the redundancies in the system, or maybe Lee talk about the redundancies in the system, and electric motors, the systems essentially being twin engines. And this comes from this particular requirement that this electrical system perform after a single electrical fault. And I've listed a few of the failures, possible failures. There are many in an electrical system. It could be motor failures due to phase-to-phase shorts or turn-to-turn shorts, power electronic failures, contactor failures, and motor controller failures. So, the system. Sorry.
We have 3 minutes left in the entire session.
I got.
If you come up so we can just.
Okay. So anyway, in the presentation for people to see, I list 3 of the main concerns in terms of design of electric propulsion systems, and that's provides. Right now, we're in the position of identifying a means of compliance with the FAA. I think most projects are at that point in their certification program.
Sorry to cut you off there.
Sorry, that's fine. Ken, if you want to jump to questions, that's fine. We can do that.
Unfortunately, I think we have a hard stop at in 2 minutes. But the question I would have for you is, you're one of the few players developing an electric helicopter in a field of over 480 electric VTOL aircraft. You're a bit contrarian. Is there a large market?
Well, as I mentioned, there are over 7,000 R44s in service, or 7,000 that have been built. So they're an incredibly popular utility aircraft. And I think the application of a helicopter is very different from some of the urban transportation applications. It's a utility aircraft. Has a very different application than a fixed wing. So I think there is a large market for it. It's been demonstrated through the sale of the Robinson R44 helicopter. The big question is, does it have a useful range or a useful endurance? And I think battery technology is going to develop. We're going to see step improvements in battery technology, and it'll give it the range that it needs. Our goal is 1 hour. We think that's a very useful and achievable range for the Robinson helicopter.
Our 2 other panelists, I wonder if you just come back on. I think we have a hard stop at now. Unfortunately, we ran a little long. There's so many questions I would ask of you. I don't know if the powers that be can grant us a minute or 2 more, but if I was to ask both Kevin and Lee.
Ken,
yep.
This is Yolanda. Go ahead and take another minute for a question.
Okay. So the key question I would have for you is economics. In my prior conversations with all of you, you said one of the key drivers of what you're doing is to reduce the aircraft operating costs. And for the audience, can you give me a number versus
Yeah,
the aircraft? What kind of benefit?
We've demonstrated a 31% fuel savings on the electric eel in operation, and anticipate in call it the 25% fuel savings on the turboprop planes. Maintenance, we also expect a decrease in the cost to maintain, but still want to prove that out before quoting numbers.
Lee, what's your sense?
Yeah, well, on our project, being pure electric, our direct operating costs are down by a factor of 20. I mean, it's a huge delta. And then the secondary effects there are, as Kevin was saying, the maintenance is totally different on electric. We expect a MTBF, or a service life of 10,000 hours or more on these electric motors. The how you get that power is definitely up for debate, right? Batteries are expensive. Batteries will have a life to them. So to get to the final answer, we need the total life cycle cost, which is not we're not quite there yet. But I think the bottom line is we can all see clearly, as Kevin has demonstrated, we should be able to have the direct operating costs easily. And then of course we get all the environmental benefits and the noise benefits and safety benefits that go along with it. So it's happening, right? It's happening right now.
And Glenn, for you with the R44 versus the E44, do you have a sense of what kind of savings?
I don't have anything to quantify it, but I do agree with both Kevin and Lee on the percentages that they are quoting. It seems to make a lot of sense to me. Just in terms of the generation of power, we have the sun. The sun is free energy. We can use solar for recharging, and I think you'll see us demonstrate that this year, that the aircraft can be powered purely from the power of the sun and recharged, and it's quite achievable. And as battery systems improve, or at least the storage systems improve, I think that'll become more and more viable, and it'll open up more areas of the globe that are currently inaccessible to aircraft because of the logistics of getting fuel to those locations. So yeah, I think it's exciting times.
Well, I wish we had a lot more time, but we don't. But it's great to get the tip of the iceberg and a flavor for what you're doing in your respective companies, and also what innovations taking place on the STC front. Watch the Vertical Flight Society's eVTOL.news for further information on this sector. And with that, I'll turn it back to Yolanka. Thank you.
Thank you, Ken, for moderating the session. Thank you, Glenn, Kevin, and Lee for participating. Really appreciate it. It was a great session. And now I'm going to roll forward to our next session, which is on public services and defense, some of the earliest use cases that we are looking at in this new industry. And because I already introduced Mike Hirschberg as Executive Director of Vertical Flight Society earlier, we'll save a minute or two and I will just hand it over to Mike. It's your panel.
Awesome. You hear me okay?
Yes, I can hear you just fine.
Thank you. And we have Colonel Diller, are you on?
I am on. How do you hear, Mike?
Excellent. Good. I got you. And Katerina?
Hi, how are you?
Excellent. Great. All right. So we're a little bit behind and we got a lot of discussion to go on here. So we'll jump on to Colonel Diller for him to lead us off. So Colonel Diller is the director of the Air Force's AFWERX, which includes the Agility Prime Initiative. Colonel Diller received his commission from the U.S. Air Force Academy in 2000. He served as an executive officer to the Air Force Scientific Advisory Board, SAB, and as a DARPA Service Chiefs Fellow. He was Assistant Director of Aeronautics at the White House Office of Science and Technology Policy, OSTP, and he first spoke at a VFS event at the 5th Annual Electric VTOL Symposium in January 2018, and he's been a prime mover in gaining U.S. government support for electric flight ever since. So Nate, over to you.
Super. Thanks so much, Mike, and thanks for the great work that this entire community has done. Here in AFWERX, I actually have the opportunity to be here at the Air Force Research Laboratory today. And I think, Jim, if you have slides, great. If not, I'll try to, I guess you get to look at me here at the Air Force Research Laboratory. If you can't pull those up, if not, we'll keep going, or I can share them as well. But yeah, this is really a phenomenal opportunity, and it's been exciting to see the evolution, as Mike said, since first chance I had to really engage with this community. So I'll talk just briefly about the work that we're doing.
Colonel Diller, so sorry to interrupt. We'll have the slides up for you momentarily.
Sounds great, thanks. So I'll do just a little bit of an introduction to what we do here in AFWERX, because I think it may be helpful for many of the folks to understand a little bit the role, in a different role maybe than you might have perceived DoD playing in previous times. And so in AFWERX in particular, we are looking to see what is possible from the acceleration of technologies in the dual use space. Where can we, as the Department of the Air Force, start to engage with the small companies? When we look across the future of technology development, we see a market where 80% of research and development is actually happening in the commercial sector. And so we're looking very keenly to be able, with this mission of AFWERX, to transition that agile, affordable, and accelerated capabilities, bringing together those technology developers with our airmen and our guardians. And we'll be launching a space prime here in the not so distant future, modeling a little bit this agility prime approach and seeing that as a different approach going forward. If we go to the next slide, thanks a lot, Jim, I appreciate it. So for AFWERX, we previously, great things have happened in terms of the capabilities that the Department of the Air Force has brought to fruition. You can see many of those things fill our skies today, and it's created fantastic security for our nation. At the same time, it's followed a pretty regimented path of a few large technology providers, a group of folks like myself that spend time working in the Pentagon with a relatively limited set of ideas that you might find there, and with an acquisition approaches. If you go to the next slide, our intent is certainly to continue to leverage all the great work that those folks have done, but we would also like to be able to take advantage of a broader commercial technology space through our AF Ventures program, a broader space of talent looking across our entire Department of the Air Force, our airmen and our guardians that are out there, and then finding alternative paths to make sure that we can get these technologies, right, the combination of technology, the combination of talent, turn those two things into capability through this approach to transition. And this approach to transition is really where Agility Prime and this larger Prime program have started to fit in. And so that's what I want to spend a little bit of time on. But just before I do that, we'll walk through a couple of other slides to give you a little bit of a sense of different opportunities for technologies that are out there. If you go to the next slide, please. Now, under this Ventures program, right, the idea is being able to, for companies that are out there, and I'm sure many small businesses, they might have had the opportunity to win these initial $50,000 awards. At first, that doesn't sound like that much, but really it's less about the funding and more about establishing that relationship with those airmen and guardians that are out there to eventually propel a couple of different approaches. One could be a prototyping approach leading to a phase 2 SBIR for somewhere on the order of $1 million, $750,000 up to $1.7 million. You could also create, though, an opportunity for pairing and being able to work with other innovative companies to find alternative paths into eventually a scale, and whether that scale is with our Department of the Air Force, directly with some of these contracts. We've taken companies within a year from $50,000 contracts to $40 million contracts, and we look to continue to do that. But we also see a path where these initial feasibility studies, initial prototyping studies, actually also provide a good opportunity for matching with other companies that could eventually get that technology in the hands of our service members. Next slide. So that's the approach to AF Ventures. So far, we've seen a really phenomenal success of almost $5 of non-small business funding for every dollar of small business funding. So that those additional dollars come in some cases up to $2.2 billion of private follow-on capital through non-defense commercialization, up to $1.4 billion in follow-on defense contracts out of the small business. So far we feel like this is an approach that is really doing a lot to stretch the taxpayer dollar and provide accelerated capability to our Air and Space Force. Next slide, please. And when we look at that Air and Space Force, part of this eventually is, where are those emerging technology sectors that are out there that we might, as a Department of the Air Force, be able to accelerate? One of those, a few years ago, starting with recognition in the program Agility Prime, a formal launch last April, really kind of initial discussions of that program in the fall of 2019, where we look to see, in this potential electric vertical takeoff and landing market, is there an opportunity to leverage some of our government resources to accelerate the fielding? And this comes through an approach of co-investment with industry, looking to field within 2 to 4 years, ideally, in some cases, looking at almost a 20-to-1 partnership with commercial industry in the investments that are happening. In many cases, what we see are capabilities, aircraft that are of high interest to the Air Force that we feel like we can and will bring to the field. That comes through a partnership, that partnership looking at industry across the investment sector, working with interagency. In many cases, there's regulatory hurdles, and so working closely with NASA, with FAA, Department of Energy, looking at our international partners. Where is there opportunity for collaboration? Looking here with our laboratory, the Air Force Research Laboratory, where I am today here in Wright-Patterson Air Force Base, across the acquisition community with that rigor that is necessary to actually take something to the field. And then in the end, making sure that we have someone there for the Department of the Air Force that's going to use that. Next slide, please. So, and the intent is to prime that pump to advance our national security and our nation's prosperity. So Agility Prime was our first example of this, right? This coalescence of these three technologies of large electric power systems, autonomy, or the simplified vehicle operations, and different approaches to manufacturing that allow a concept of these small electric vertical takeoff and landing vehicles to start to carry notable payloads. You can see one of our performers in the picture there, which is Lift. That is our Chief of Staff of the Air Force, and a demonstration that was done back in August of last year. More recently, that company did a demonstration in downtown Austin with the full scope of our 4-star generals responsible for requirements and capability development. This is one of many companies. I'll talk a little about the different areas of interest that are out there. The question, why is the Air Force interested in it? Well, we see this as a potential strategic market for our defense industrial base that could be worth trillions of dollars in the next decade or two. We also see this as an opportunity, secondly, as a way of improving our processes, the processes that we use for adjusting near-term budgets and creating some budget flexibility, processes for our airworthiness. We now have 4 aircraft through the airworthiness process just since December of last year, when Joby made news as the first company. And then eventually product. We are very interested in future concepts, finding ways to have this vertical takeoff and landing capability support our folks in the Department of the Air Force through logistics, through different approaches to potentially personnel recovery, medical evacuation. We've outlined over 20 different use cases that are out there. So how are we doing this? Well, it's through collaborative risk reduction, being able to use some of our technical infrastructure to reduce that risk that many of the small companies have out there, being able to allow them access to our ranges, to things like wind tunnels, to ground vibration testing, to acoustic testing, to cyber resiliency exercises, to operational testing. Eventually then in the regulatory risk reduction, providing early military airworthiness, and then the financial risk. We do and have contracts for those companies as an early adopter of this technology and looking to field it. So far we have 24 different companies that have applied. I actually think that's up to 29 now. 4 aircraft that have gone through our airworthiness process, over $100 million in contracts, leveraging literally billions of dollars of commercial investment. We have a training command set up with a colonel charged with understanding how to maintain and to operate these aircraft, and then a multitude of different aircraft that have been delivered both from an aircraft and a hardware perspective. Next slide, please, and I'll finish on this one, hopefully keeping us on time there. And so as you look at the approach that we've taken, we have this idea of this air race to certification, as we called it. And that air race to certification has the 3 different steps here, looking at the solution briefs, eventually to a site visit, and then an opportunity then for these prototype proposals. In this air race, we've called 3 heats, or these 3 areas of interest. And this has been exciting for us because each area of interest has a different capability that we're really able to accelerate learning through these larger passenger vehicles for what was maybe perceived as this urban air mobility. Some of the smaller passenger vehicles, 1 to 2 passengers, taking advantage in some cases of the FAA's Part 103 capability, and then the larger unmanned cargo aircraft. As we've done that, it's been exciting to see, just over the last couple of years, these ideas really now starting to take flight. With, like I mentioned, just in the last week or so, our 4th performer getting through that airworthiness. We believe that as we continue to fly these aircraft, as we see the fantastic opportunities for near-term use cases, that there is real capability to bring this to the field, to think differently about partnership with dual-use providers out there for what could be a very notable change in the way we think about air mobility in the future. So with that, Mike, I'll pass it back to you, and thanks so much for the great opportunity.
All right, well, thank you. We really appreciate your leadership and driving this this capability forward for government support. And I think things would be a lot different if the Air Force hadn't really seen the thing that we had all saying that this is a really revolutionary capability. So thank you again. Appreciate your support. So next we move to Katerina Barilov. We're very happy to have her today. She's the co-founder and business development lead at Jump Aero, which is a startup building an electric aircraft designed to help first responders and EMS personnel save lives. Katerina has extensive experience in aviation, structured asset-backed finance, and corporate strategy. So Katerina, thank you so much.
Thank you very much. It's great to be here, and this is a fantastic program, and thank you. Thank you for giving me the opportunity to tell everybody what we're up to. I'll do something a little bit different than our standard presentation, which is typically more of like an explanation as to what we do, and maybe take some time to explain what we learned. So my personal background is primarily in investment banking and specifically in structured finance. And most recently, I joined Jump Aero, where I'm responsible for all business development, along with my co-founder, Carl, who's kind of responsible for making the actual thing happen. I'm more responsible on like making it profitable. So I'll tell you a little bit about who we are. So if you could please advance this slide. So everybody who's on the call, who's listening to this, knows that eVTOL technology is meant to be a huge industry. There's a lot of numbers being thrown around. Most recently, it's $9 trillion by 2050. A lot of that is focused on transportation. So transportation of people, whether it's commuters or whether it's kind of shorter hops in regional airlines or it's freight. But not a lot of folks are kind of talking about, well, how do we fill in the rest of the ecosystem, and how do we think about kind of bridging the gap between what we have now, which is more like traditional transportation, and the future, which is a lot more profitable, a lot more green technology, which is hopefully going to take over transportation as we know it. So for us, if you could please advance the next slide. The thesis is that rapid first response is the highest and most immediate opportunity, highest rate of growth and the most immediate opportunity within the eVTOL ecosystem for newcomers such as ourselves. So while a lot of folks are out there are focused on air taxis, and we believe that that is wonderful and great, and they're building the aircraft specifically for that, we're focused specifically on rapid first response because we believe that it's the fastest way to get to market. Not only is it immediate in terms of there's a need now and there's a growing problem, there's also a lot of benefits kind of that I'll talk a little bit about more. But most importantly, we can utilize technology the way that it is now, where eVTOL technology has evolved to meet the needs of EMS as they are needed. So just to kind of give you a general brief overview of how big this problem really is, in the United States alone, we're not even talking globally, you can save up to 10,000 lives if you can increase first response. So there's a lot of rural communities, there's a lot of instances in which there's an elderly population that doesn't have access to fast EMS. And by fast, we're talking about under 8 minutes. So for time critical emergencies, instances like strokes or heart, like cardiac arrests, every single second counts in terms of probability of survival. And that's really what we're focused on, because the benefits, as everybody who's been listening for the past day knows, of electric aviation versus traditional aviation is that you can spool up a lot faster, you can get boots on the air a lot faster than you could with a helicopter, and you can fly a lot faster, but for shorter distances. So this is kind of like what our sweet spot is in terms of this is what we would like to use our technology for. So if we could advance to the next slide, tell you a little bit more about what we're doing. So Jump Aero, we are enabling the fastest emergency care that's currently available, meaning that we are not transporting the patient, unlike the current method of EMS, which has been traditionally focused on transportation. We're really coming in to a change in pre-hospital care, where right now, when you talk to ambulance providers who are getting more and more sophisticated, they will tell you that there's been a bigger shift towards providing care on site. So avoiding more preventative emergency care versus dealing with it at the hospital, if that makes sense. So doing as much as you can to triage the situation on scene. So ambulances are becoming more like rolling clinics, and not like hearses, which is kind of where the industry came out of. It was like literally like throw a guy into a car and he either gets taken to funeral home or the hospital, depending on how the ride goes. Now, obviously, that's not where we are. Now it's a lot more, how do we deliver the best care to the patient to prevent additional costs down the line, cost to the hospitals, and more importantly, cost to the insurance providers. So insurance providers are highly motivated to kind of prevent future damage, if that makes sense. And when you have restriction of oxygen, you have restriction of blood, if somebody's bleeding out, those are every single second counts. So for us, we are focused on getting the paramedic to the scene as quickly as humanly possible, as opposed to transporting the patient, which we believe is a perfect opportunity for eVTOL technology to make a difference. So we are building a single seat aircraft, which will have the fastest spool up and dash speeds than anything that's available right now. And we believe anything that will be available when we come to market, which will enable us to essentially create a paradigm shift in first response. So instead of calling 911 and hoping that you'll get to the hospital on time, you'll be able to call either Jump Aero or 911 and have a Jump Aero aircraft come to you and have a qualified medical provider be at your side, delivering whatever care you need and not worrying about when that ambulance is going to get there. So that's what we're doing. We believe that it's a huge problem. We believe that there are over 3 million time critical medical emergencies each year in which we can make a difference. We believe that those 3 million time critical medical emergencies translate to more than 12 million potential eVTOL deployments. And that's just not only for critical emergencies, that's also to free up paramedics, to free up resources of very strained EMS systems, to be able to take care of short palliative calls, kind of like traditional, like more predictable calls, so that the ambulance doesn't need to be dispatched for every single one. So we can go to the next slide. So this is a little bit about our design. We're keeping everything highly under wraps for a variety of reasons. But what I can tell you is that we are totally focused on 2 big issues. Number 1 is simplicity. Number 2 is performance. We believe that if we can hit hard on delivering very simple, highly performing aircraft, then we will win. we are participating in the Agility Prime program that Colonel Diller just talked about. We have multiple Air Force contracts through that program. We have patents pending, and we are focused on the software as opposed to the hardware, again, for simplicity's sake. All of this to arrive to what we believe will be the fastest way for any human being to get between any points within 60 miles. And that's really what we're building. And that's kind of like what makes us special. So I'll go on to the next slide.
Katerina, just one quick moment, so sorry to interrupt.
Yep.
Colonel Diller, if you don't mind muting your microphone, it's not letting us mute you, and there seems to be a bit of feedback happening. Okay, sorry for the interruption, Katerina.
No problem, thank you for coming in. So shifting a little bit away from like a standard pitch, I know that folks here are a lot more interested in kind of the future of electric aviation and not so much about kind of us and what we do specifically. This is kind of what I learned in my year and a half of working at Jump Aero and building a business with an EMS. EMS, like I just pointed out, I think is a really interesting business case for eVTOL technology. However, there are challenges and kind of idiosyncratic things that maybe don't exist in the traditional transportation space, and I'd like to go through them. The first is that, you know, you're not really fighting community acceptance the same way that you are when you're thinking about building an air taxi business, particularly when you're building an air taxi business with new infrastructure in areas where folks are not used to a lot of traffic, where potentially your tickets are going to be on the higher end. A lot of businesses should anticipate dealing with municipalities to talk with the communities to understand how this new technology is going to integrate with potentially highly residential areas where right now there isn't a whole lot of traffic. For us, that's not a problem. So we're not as worried about disturbing the peace, so to speak, because as the situation is now, we're already perfectly happy with having our peace disturbed by ambulances and helicopters because we know that they're on life-saving missions. So that's a great thing. The other great thing is you get higher margins. You know, obviously people, you know, are willing to pay a lot more for life-saving measures than they are for traditional transportation. Sorry, there's a helicopter flying overhead, so sorry if my audio is hard to understand. And you also have a faster path to market. You know, you don't have to build up the infrastructure, like I was saying. You don't have to build a whole new business. There's already an EMS industry that you're sort of plugging and playing. However, there are a lot of issues with it that I think anybody who is going to be thinking about applying eVTOL technology in EMS should not underestimate. And the first is that it's a highly fragmented world, meaning that, you know, depending on where you are in the world, EMS is organized either by state or by country, or even times where I live in California, by county, which means that you are, you know, talking to customers individually in different counties, in different states, in different municipalities, and their needs are going to be very different. And so that's something that you need to anticipate if you're thinking about launching your OEM, how that would work. Also, it is highly regulated. So anybody who's launching this business needs to understand how to work either alongside certified ambulance providers or how to get certified on their own if they're going to be providing their own services. And it's an industry that is steeped in tradition and has a huge reluctance to change, which really cannot be overstated. And so that's kind of it in a nutshell. Again, not to discourage anybody that this is like a very, I think, a great application, but there are certain idiosyncratic issues that definitely need to be considered. So if we can go to the next slide. This is something that I just want to touch upon. I'm not going to go into depth about it. It's not my personal area of expertise, and it's not really what this presentation is about. But suffice it to say that any OEM worth its salt should have a slide on certification. One of the things that we think our application is going to help us in certifying our aircraft is that we can use public use aircraft operations. And there are alternative paths to operations outside of just a standard TC that are unique to the fact that we're going to be operating as a public service. So that's something that we think is a big focus. I also, the fact that we're level 1, again, we're not transporting patients, and that's in a major part due to the ability to get level 1 certification. We're not going to be operating under part 135. We're going to be part 91 the whole way. That's not to say that that's not in the future, but again, our focus is to get to the market as quickly as possible. And I'll finish on my last slide, which is just a general overview of kind of who we are. For those of you who aren't familiar with us, we're all over the United States. That's one thing that COVID was helpful with, is being able to pick up folks that are experts in the industry who are spread out all over the place. And so for those of you who aren't familiar with Carl, he is the co-founder and CEO of Jump Aero. It was sort of his baby, and he is the previous founder of Terrafugia, so he's pretty well known. Jeff is our production and fabrication lead, and he's also out of MIT, and then myself, and also some familiar faces as head of systems and certification. So I'm going to keep that brief and bow out. I think I'm maybe past my limit of 10 to 12 minutes, so apologies, but I'll pass it on to the next speaker.
All right, great. Thanks so much. And guys, apologies for the noise there. Colonel Diller had 2 mics and or 2 connections and was changing locations. So apologies for that, but we got that that open mic clamped down, I think. So our third speaker is Johnny Du, who's the president of the International Vehicle Research, which focuses on innovations in flight vehicle technology, product development, and applications. His efforts include strategic consulting with global customers on business planning, product development, and market strategy. He leads NASA's Transformative Vertical Flight Working Group on public services, and I think you've led that from the inception, back from our 2017 electric aircraft symposium, right? So thank you very much, Johnny, for all your leadership, and I think you were a big contributor to the early work that led to the Agility Prime. So I think we have a lot to be thankful for your efforts in this area.
Well, thank you. I think that's a tremendous teamwork, and thank you for the support right off the back, right at the beginning, get the whole thing started. With that, I'm going to focus. I mean, there's a lot of eVTOL uses, and we can't cover them all, but so I would be just focusing on the eVTOL for firefighting and natural disaster response today. I got quite a few slides to cover, so I will hit the highlights. Please feel free to contact me or look me up in the LinkedIn if you'd like to discuss the topic further. I will take the opportunity to elaborate on what Mike was talking about, this transformative vertical flight working groups organized by NASA and with a strong support from Vertical Flight Society and with partnership on Agility Prime. We have 4 working groups, from Working Group 1 for private recreational vehicles, focus to Working Group 2, commercial intercity, which is a shorter range like urban air taxis and so on. And Working Group 3 is focused on the commercial intercity, which means a little bit longer range. You can hop from city to city, urban area to longer medium range target locations. And Working Group 4, which is my team, is focusing on public services. There's a lot of possible applications. I think you already heard our 2 speakers covering some of that. So with the team, what we do is we look at the different mission elements, including search and rescue, law enforcement, firefighting, medical transport, military operations, as well as emergency humanitarian response. And we also work on the roadmap to look at technologies, certain regulations, infrastructure, as well as acceptance to enable the application of eVTOL or transformative vertical flight type vehicles, systems for public use. We also are getting pretty close to release a white paper kind of outline some of the opportunities and challenges we're facing. And by the way, if anybody who interested, please contact me. Welcome to join our working groups, whichever groups pick your interest. Next slide, please. And just a quick outline of some of the applications and potential operators. I mentioned those applications in different areas. Within each major category, there's many different situation and application operation possibilities. Also, you can see that this is just a short list of some of the potential operators that can take advantage of the platform and the systems. So with that, next slide, please. So let's talk about jumping to today's main subject, firefighting. This is separated into two major categories. One is the urban and suburb firefighting. That operates a little bit differently than the say wildfire. So let's talk both. One is that if it's a urban suburb, it could be early deployment from the fire station to the scene, as well as even high-rise building fire suppression that couldn't get to it by a traditional manner. Of course, wildfire management is very different. Okay, it's a large scale, large area. The response methods and the capacity requirement is also different and challenging. One of the best application I would think is early application will be short range, compact eVTOL that not only we can deliver the firefighters into the wildland to counter and control wildfire, but when the fire changes directions, sometimes people get trapped behind the fire line, but we're able to get them out of the harm's way quickly. Next slide, please. And of course, there's a lot of challenges, including the vehicle-specific capacity, capability, hovering endurance. Perhaps we need to develop the swarm capability to counter and control fire, especially at the early stage, prevent them from even become large ones. Transportability is important. Sometimes we can't land, and we need the devices that we can get people in and out the fire zone. Of course, airspace management, autonomy is going to be critical in this kind of environment. We can't expect every firefighter to become a pilot. So we need to be fairly autonomous capability. Next slide, please. And of course, operation, logistic, you guys can imagine how challenging that can be, to mobilize a lot of assets and support the charging systems and so on. I think we have a way to get there. Just need to realize the challenges and plan accordingly. And of course, we need to evaluate how is the best way to use eVTOL. It's not going to be a helicopter. It's not a fixed-wing airplane. It's different kind of capability and limitations. And we need to learn through practice how we can best utilize the eVTOL systems. Of course, mobile charging station is going to be critical to make that happen. By the way, there's also an SAE research report coming out next month on this topic. So let's talk further. Next. And talk about natural disasters. Well, I think, there's a lot of natural disasters. Unfortunately, I mean, we are seeing that ever increasing frequencies and scale of the natural disaster recently. And let's see what eVTOL, if eVTOL can help. Next, please. And some of the common challenges, opportunities, and development needed. One is logistic. I kind of touched that. We'll probably need to meet into long-range distance deployment capabilities, as well as the short-range last-mile capability, service repair, spare parts into large-scale disaster area, and charging capability. Sometimes not just charging. Where's the electricity is going to come from? We may have to provide fuel to the charging station in order to fuel the electric airplane. And of course, a landing site, forward operating base, where are we going to use it? Parking lot, GA airports, electric truck stop, maybe. Next, please. And of course, charging, as I say, is one of the key challenges for all public service operations, especially in natural disasters. And of course, there are efforts ongoing, like I say, AE7D committee working on trying to establish certain type of eVTOL charging standards. What I'm hoping for is that eventually we will be able to leverage the ever-growing EV charging stations and the forthcoming future electric truck megawatt charging systems. That way, wherever we go, if the power is still on, we have the capability, even put on adapters or extension cable or whatever it takes. Next, please. And of course, airspace management is going to be critical. Fortunately, NASA has a program called the Stereo, and leveraging the UTM effort that we're already put in place, try to move forward, enable the on-demand theater command and airspace management. Next, please. And one of the key things, if you look at the recent what happened in Germany, that's what this map was showing, that the flooded areas and so on, not just Germany, the whole Europe, really quite a bit of Europe, and it's large-scale disaster in many areas. So what we could do is establish a distributed on-demand emergency response and disaster relief network, so that we can leverage a large fleet of either air taxi or typical emergency response units, move them into the disaster area quickly to save lives and help people. Next. And of course, flooding, some of the challenges may be that, okay, eVTOL doesn't hover too well in many of the designs. So what can we do? If the flood velocity is not too high, we can land in the water by adding a float, right? But in some cases, we may need some platform that can hover better. I look at whether we can land on a rooftop. I say maybe that's a little bit challenging. Next, please. Of course, some of the enabling capabilities, functions, may not need to be all-weather capabilities. At least be able to operate in heavy rain, because some of the disaster situation, you need to be able to get in at the early stage to get people out of harm's way. Next, please. Okay, let's jump to the hurricane typhoon. There's a couple of lessons learned. The good thing is the forecast available and it's getting better and better. And even the trajectory is getting good. And let's go to the next slide. But there are some challenges I realized through the case study on the last Hurricane Sally in the Gulf Coast area. That map is showing that that's a power outage map. So if we rely on traditional infrastructure, even if we have a fleet of eVTOLs to go in, that fleet of eVTOL may have a charging problems, and we probably have to have some mobile system to be able to move into the theater, to be able to recharge the system, airplanes, and so on. And the fuel supply needs to come with it. Next, please. And this is showing some of the damages that in our neighborhood. That lower right-hand corner, lower corner. That I guess the guy is thinking, well, maybe my swimming pool was not big enough when I built it. And the left-hand side lower corner, basically, that's a new definition of what the boathouse was going to mean. But what I really want to point out is the upper right-hand corner is that even the gas station got damaged. One of the neighbor came in and say, okay, I brought my generator. I got a 5-gallon fuel, but he ran out of fuel real quick and ended up he has to drive an hour to get refueling his generator. Well, why is it important for generator? Because food, all our refrigerated food are going to go bad if we don't have power. So we think about the emergency response. In some cases, actually provide food, fuel into the disaster area is actually quite critical. Next, please. And some of the early response, I think the jump arrow is right on target, because sometimes the trees down, heavy rainfall, trees down, road blocked, can't get to people. People get hurt. We need to get the medical personnel right into the target area right away to help stabilize the patients and so on, the injured person. And if necessary, get them out to the hospitals and so on. Next, please. And of course, tornado, the good thing is it's narrow paths, 1 or 2 miles, so nearby stuff is good. We can converge quickly right after tornado. Unfortunately, nothing's going to be left on the path. Next. Next slide, please. Yes. And earthquake, one thing we're going to need is probably eVTOL with robotic landing gear that can adapt to uneven terrain, because that damaged area, you're not going to find place to land. So we want eVTOL fleet, but we want special capabilities. Next, please. And tsunami, the challenge is it's large area, and we need significant size of fleet in order to go in and help people. Possibly a last-minute evacuation. If the epicenter is a little bit further away, you have a few minutes of 10 minutes warning to before it hits. So we might be able to leverage the air taxi fleet to get people out the best we can. Next, please. And of course, volcano, the challenge is, well, the fine ash probably going to really create some problem for electronics and the motors and the rotor blades and so on. So, next. And we already talked in the snowstorm. You know, you guys can imagine how that can be beneficial with eVTOL capabilities. And next. And wildfire, we already talked about that a little bit. So with that, I'm going to pass it back to Mike.
All right. Thank you very much, Johnny. That was great. If we could have our other speakers come on camera. Colonel Diller, are you still there?
I am. How do you see?
All right. I like your new, you know, some people have electronic backgrounds that change. You know, you have actual physical backgrounds that change.
Thanks. Sorry for the.
So yeah, so thanks everybody for rejoining. Lots and lots and lots of questions here. I will say, Santh Sathya from Luftcar has posted quite a number of questions. I will say, you know, first of all, I think everybody said you could reach out to you guys through LinkedIn, and also VFS members can use the directory. So we have 6,000 members, 6,500 members. You can reach people in their directory if you need to connect with people. So a couple questions here, Colonel Diller. There was some more. He had some questions about like the next phase 1 AFWERX submission due dates. Are you having? And I guess that's for, I don't know if that's for SBIRS or for your race to air certification.
And so we have through the end of this year, we still have the opening for our innovative capabilities opening. So you find that at afworks.af.mil or just directly to agilityprime.com. And you can find the documents there through the end of this year, likely depending on kind of our bandwidth and interest, continuing that into the next year. Separate from that is our small business innovation research and small business innovation technology transfer programs. Those happen 3 times a year. So expect the fall solicitation. We're in the middle of some of our awards. He'll be coming up next in the next couple of weeks for our summer solicitation, and then we'll have another fall solicitation. They'll be coming up here in another couple of months. You can find more information at afworks.af.mil.
Great. Well, we appreciate all the different opportunities that the Air Force is providing to the nascent industry and academia and moving the ball forward. So Katerina, there was a couple questions for you. Thanks for answering the one in the chat. And somebody is asking about one person versus 2. What do you think as far as you know, what are you guys looking at for that, for as far as 1 versus 2 and the pros and cons?
So I guess the most obvious pro of 1 is the ease of certification, because you're not carrying any passengers and you're level 1. Obviously the drawbacks are the fact that training is going to be more challenging, and so we have to work in like simplified vehicle operations as much as we can into the vehicle and creating a very safe training environment with regards to the simulator and stuff. I mean, for us, the decision was fairly easy because we're just trying to, again, focus on simplicity above all and focusing on getting to market. And speaking with all of the EMS providers that I've personally kind of gotten a relationship with, it's really getting a medic and a qualified person to the scene of an emergency. That's the most important thing. Two would be better, but for us, it's really kind of under promising and over delivering right now is the goal. So
sure, and certainly certainly the technical challenge of building a larger vehicle and cost and performance, everything else as well, I'm sure.
Right, yeah, and you know, for us, it's so specialized that we want to leave enough room for highly technical baggage, if that makes sense. So we're going to be carrying an AD, we're going to be carrying an automatic. Sorry, my cat just tried to attack me. We're going to be carrying an AED, we're going to be carrying an auto pulse, so that one person will be able to do CPR effectively, in the med bag, and so all of that takes room, and we want to be able to build in an appropriate weight and space allotment.
Okay, great. So Johnny, there's a question on how to join the working group. So can you give people the URL for people to join yours or other working groups?
Sure. I will, if I can figure out how, I will try to type into the, or just contact me. Contact me. I will get you arranged and sign up.
So I think that's one. Is that nari.nasa.gov? Is that the place where somebody can start? Okay. Yep. So NASA's NARI group was at NASA Aeronautics Research Institute. You can find it on there, the different working groups. Colonel Diller, we know that Joby is flying on Fort Hunter Liggett. I'm not sure if any of the other companies have flown on any military bases. I guess, can you give us some more information on? Are you flying aircraft on Air Force or other military bases, and you know, who will fly these types of aircraft in the Air Force?
Sure. So we have 4 of our companies that we now have publicly out. Joby being the first. Then we have Lyft that I showed on the slides there. We also have Beta, which was the first company that had their airworthiness for manned flight. They're flying out of Vermont there. And then the last was Kitty Hawk, flying out in California. We've had a couple of cases where they're flying on some of our government locations. We're really trying to support the companies to fly where it makes the most sense for them at first. And in many cases, you know, being close to their engineering teams, what's exciting is to start to see now that they're stretching their legs a bit and being able to have really a higher tempo of flight test available, longer flights, longer endurance, longer range. And so we're now looking over the course of this summer at a series of use cases very similar to the ones that Johnny and Katerina had mentioned, that are dual use cases, and looking to see then what does that start to look like as we go from some of the developmental testing now to operational testing, and then starting to look at some of those early fielding cases. And we think there's a lot of promise, especially in some of our early logistics cases, and we may be looking at these early cases being either manned or unmanned, remote, and then in some cases we've been impressed with some of the autonomy work that is happening already. So exciting times.
Great. Well, I think we're probably not. I don't want to go over into the next field, into the next group. I appreciate everybody's not only doing the presentation today, but really the work that you guys have done in areas to advance the conversation and to save lives and provide more benefits to society from electric flight and electric VTOL. We, you know, certainly the Uber air taxi mission got a lot of press, but other, you know, this is like developing, you know, the turbine engine. It's all kinds of different applications that can now benefit from electric power. So again, appreciate your guys' leadership and all that you do, and both for your organizations and for the electric VTOL revolution in general. So Thank you very much.
Okay.
Thank you.
And thank you to Katarina, Johnny, and Colonel Diller and Mike for moderating that panel. And we now come to the last panel of the day. I'll wait for Chris to put that slide up. I'm going to, there we go. And I think we have a mic on, hot mic somewhere. Thank you. I'm going to take off my Cafe Foundation hat for a moment and put on my CAMI hat for this and moderate this panel. I'm the executive director of CAMI, the Community Air Mobility Initiative. We are a nonprofit education organization that I co-founded with Anna Dietrich 2 years ago, with the mission to support the responsible integration of the third dimension into community transportation plans through education, communication, and collaboration. So we work with state and local decision makers, planners, businesses, and communities to help them understand what advanced air mobility is and to look at both the opportunities and the challenges of implementing advanced air mobility into their communities. So it is with that hat on that I'm really pleased to moderate this panel on community integration. We hear a lot about the technology of these aircraft and the progress that has been made there, but we're starting to see that some of the real challenges come both with integration and with implementation into local communities. All communities are different, they have different needs, they have different perceptions, and public acceptance is an important consideration as we continue to move forward with the advanced air mobility industry. So I'm very pleased to have Adam, Adrian, and Scott all on this panel. We're going to start with Adam Cohen with for the first presentation. Adam is a mobility futures researcher with the Innovative Mobility Research Group at the Transportation Sustainability Research Center at UC Berkeley. His research focuses on innovative urban mobility solutions, including urban air mobility, shared mobility, urban goods delivery, automation, smart cities, smartphone apps, and other emerging technologies. And I also want to say a personal thank you to Adam, who is one of CAMI's expert contributors and has certainly contributed so much of his expertise to the resources that CAMI has put together. So Adam, I will turn the presentation over to you.
Thank you, Yolanda, for the introduction. Can you hear me okay?
Yes, I can hear you just fine. Scott, you might want to go off camera until you present. And Adam, I don't see you on camera.
Yeah, I will join on camera momentarily. I don't want to I've got a little bit of low bandwidth, so I just want to make sure that I get through the presentation without interruption, and then I'll join on camera for the discussion. My apologies.
Can we go to the next worries.
Slide? Okay, well, you know, this is a really big topic, and so I'm going to try to be brief and concise today, but I'd like to hit on a number of key points. I'd like to talk about kind of 3 different perspectives from a public acceptance perspective, talk a little bit about the role of equity and some opportunities and challenges, talk about how those items really kind of relate to AAM stakeholders, and kind of how we integrate advanced air mobility both into other modes of transportation and within the US DOT's mobility on-demand ecosystem. I'll also kind of talk about some kind of integration basics and then conclude with some concluding remarks and some recent resources. Next slide. So we talk a lot about the term public acceptance, but there's really kind of 3 different layers or perspectives to public acceptance. There's kind of an institutional and public sector perspective of, you know, what are the community impacts? How does an organization prepare? And, you know, how do we guide sustainable and equitable policy outcomes? There's kind of this perspective from a non-user perspective, which really kind of emphasizes safety, neighborhood impacts, and other impacts of non-users. And then there's this kind of, user impact, which is more about, is it safe to fly in these aircraft? Is it convenient? Is it affordable? And how does advanced air mobility compare to other alternatives in terms of journey, price, travel time, and those types of attributes? So I think it's really important when we start kind of talking about public acceptance that we really kind of start drilling down to each one of these different perspectives. Next slide. So in addition to that, I think it's really important to kind of mention that the role of equity really kind of has the ability to kind of impact, the adoption of these services and perceptions from each one of these different perspectives. We know that AAM has a variety of potential opportunities, such as bridging really important gaps in the transportation network, whether it be spatial, topographical, or even built environment. It could potentially reduce the mismatch between jobs and housing, especially with the growth of telecommuting. If these trips have to be done less frequently, maybe somebody's willing to pay a little bit more for a better experience. It can expand access, as Johnny pointed out, to critical services. It can create new employment opportunities and also opportunities for economic development around vertiports. However, we also have to recognize there's a lot of equity and other challenges related to this, such as environmental impacts, affordability of services, access for people with disabilities, potential issues of gentrification and displacement around vertiports, and also how we manage this idea of allocating limited public resources and where does AAM fit into kind of the overall priorities for the public sector. Next slide. So there's a number of different stakeholders that are impacted and could influence AAM. And this slide kind of really depicts these relationships. On the right are the traditional aviation stakeholders, and on the left are the local community and regional government stakeholders. And what we really see here is that UAM or AAM, as well as UAS, are really cross-cutting from a community integration perspective, because it's really about bringing all of these different diverse stakeholders that rarely had interaction with one another together. Next slide. So I'd like to talk a little bit about how kind of AAM fits into what the US DOT has referred to as mobility on demand. Mobility on demand is a concept that the federal government has kind of developed, and it's basically got this idea of providing consumers on-demand access to passenger mobility and goods delivery. This idea that transportation is a commodity and that consumers are making very dynamic choices on a daily basis based on cost, convenience, travel time, wait time, and other attributes. Next slide. This figure developed from the U.S. Department of Transportation really kind of depicts this ecosystem. At the heart of this ecosystem, we really have these connected travelers that are making these dynamic choices based on real-time information. And then there's all these modes of travel that fit into that, including AAM. And then on the right are some of the many other enabling technologies and supportive services that fit into that. Everything from integrated payment to incentives and trip planning and navigation tools, to name a few. Next slide. So as we start kind of talking about integrating AAM with other modes, it's really important we start talking about both digital and physical connections. On the digital side, this is integrating it into things like mobility as a service, integrated fare payment, real-time information integration. It's also about the physical integration, such as co-locating multiple modes together, including AAM with public transit, shared mobility, and other transportation services. And we really should start thinking about this in terms of three different kind of areas around vertiports. Kind of a core area where that hub is located, kind of a zone around that where there's a lot of these shared services that provide first and last mile connections to a vertiport, such as micromobility, and then kind of a broader catchment area that the vertiport serves. Next slide. This figure here kind of depicts three different transportation facilities. You got SFO on the upper left, the San Francisco Transbay Terminal on the lower left, and King's Cross in London on the right. And I think what we really need to be talking about AAM in the context of is really kind of making these vertiports and the areas around vertiports much more like urban rail stations and a lot less like traditional airports. And so it's going to really kind of require, I think, a change in thinking in terms of how we approach community integration. Next slide. Some other things that I think we need to also consider is, who owns, operates, and maintains vertiports. On the left side of the slide here, you can see these are just a few options. I mean, you have the private sector, where a service provider owns and develops a vertiport. Pan Am Worldport is kind of an example of that from a terminal context. There could be infrastructure owner and operators, but there could also be public-private partnerships or even public ownership of these facilities. And then we also have to start thinking about who has access. Is it open to multiple service providers? Is there a priority access where certain service providers have priority times or takeoff and landing rights, and then others have kind of secondary level access? And then, or is it a closed access where only one or a limited number of service providers have access to a facility? Next slide. Some other things I think we also need to consider with respect to multimodal integration is really kind of determine if a site is ready for a vertiport based on 4 key criteria shown on the right here. Site suitability, connectivity with other transportation modes, is there market demand to support that location, and what type of jurisdictional support. And if a site is deemed suitable, then whoever is building the vertiport really should proceed next to developing a conceptual site plan that includes integration with other modes and surrounding land uses, that defines roles and responsibilities of who will build, operate, maintain, and finance the facility, and then work with local governments to integrate and align both planning and zoning to prepare for this new infrastructure. Next slide. So I'll conclude with some unanswered questions that we really kind of need to identify as an industry here. What is the built environment that we're trying to serve? How do we integrate with surrounding land uses? How do we integrate, surface modes of transportation? And what level of public involvement should there be? And how do we mitigate the adverse impacts from both the vertiports and their location, but also the flight paths and the impact of operations that they generate? Next slide. So a lot more work is really needed to be done to integrate AAM into local and regional transportation planning. In particular, we need to very quickly deploy demonstrations and evaluations to prepare the public for readiness, to prepare institutional readiness as well, to assist the public sector in evaluating requirements and policies that either support or impede the development of AAM, to understand the impacts and to validate the technical, institutional, and policy feasibility of various deployments and use cases. Next slide. I'd like to conclude just by sharing some recent resources that our group has published. On the left side is the Mobility on Demand Planning and Implementation Guide, which includes considerations for emerging modes such as AAM, as well as automated vehicles, a recent journal article on the market potential and challenges for AAM, and also a study on the potential societal barriers for UAM. All of these links are included. And on the next slide, I'll conclude with my contact information. I look forward to our conversation. Thank you.
Adam, thank you so much. That was excellent, as always. And now I'd like to introduce our next speaker, Adrian Lindgren. Adrian is an urban planner and economic development professional with a focus on integrating advanced transportation technology into the built environment to enhance urban and regional mobility outcomes. As Hyundai Urban Air Mobility's lead for state and local partnerships, Adrian partners with entities across the globe to better understand how UAM technology can deliver universal, affordable, and human-centered cities. Adrian, I will turn it over to you.
Thanks, Yolanda. Thanks. Can you hear me okay?
I can hear you just fine.
Great. Well, thanks for having us today, and excited to talk to this crowd about how we're approaching planning for universal mobility. If you want to go ahead and flip to the next slide. So sometimes we do get the question of how did Hyundai end up in a car company, end up building aircraft? And so I always like to start off with just sort of laying out how we got here. So we actually started in transportation infrastructure and then got into vehicles about 10 to 20 years after we actually launched the Hyundai Motor Group business as an engineering construction firm. We then sort of have progressed over the last 10 to 15 years on a big focus on advanced ground and air mobility. And so we're really looking at how do we transition our products and services both towards cleaner, more sustainable energy sources, how do we better community advocates, and how do we best serve our communities through really human-centered design and human-centered vehicle design. So that rather than sort of fitting people into cars, we're designing vehicles that are going to optimize the overall transportation system. And that's where sort of we look at both ground and air as two of those pathways towards universal mobility. And go ahead, flip to the next slide. So I'm going to take, I'm an urban planner, guilty as charged. And so I thought what we would do today is, or what I would do today is talk a little bit about the city planning process and its relevance to AAM, and then talk a little bit about how we're particularly engaging in that. And I think this is a really important topic because, you know, when I got into AAM as a planner and as a transportation planner, I was really drawn to the sort of culture clash that happens between some of these traditional industries coming together around AAM. Adam did a great job of talking about what that overlook looks like. And you know, the planning process is very important to my heart. And I really do believe as we think about that concept of community integration and public acceptance, a city's plan, its comprehensive plan, frequently lies as sort of the epicenter. It's the guiding document, right? And so planning it's a political process. It involves a lot of different people and really serves to kind of monitor and plan and control the construction, growth, and development of a town or a city, right? And sort of focuses on integrating stakeholders into that planning process, mostly resulting from it being a more top-down approach historically, and a need to break out of that and be more consultative with the public to talk about. But I particularly like talking about it because I think it has a lot of direct relevance to us as sort of advocates for the AAM industry. It is a huge barrier beyond certification. It is not necessarily, UAM is not part of that planning process, and aviation in general tends to have a slightly more distinct planning process that I'll let Scott kind of probably talk about during his presentation. But you know, additionally, city planning is in many ways sort of a gatekeeper to city operations, where the public has an immense amount of influence. They take, you know, planners take their constituents very seriously, and the public takes their ability to participate in the planning process quite seriously. And the other reason I talk about the planning process is because I think we frequently hear the word sort of P3, right, or public-private partnerships in this industry. How we're going to get public funding to support some of the scaling of the AAM network. And I'm going to talk a little bit about why being in that planning process is so important for unlocking some of those opportunities. Next slide. So what does the planning process look like at a high level? There's roughly 5 phases, and they start with sort of the scoping and exploration of the project, to the feasibility and master planning, to the more technical studies that gets translated into a zoning code through a formal process of adoption, which substantiates sort of the permitting process within a city and lead to ongoing quality management, or also the operations of the planning process. It's very much my view, and I think we share this on Hyundai, you know, that advocating for UAM in the planning process should be a sort of fundamental goal of our approach, in part because it will allow us to sort of rebrand aviation as truly part of transportation, which I think, again, sometimes it's still treated as a bit of a distinct industry outside of transportation, where it requires a separate planning process. And we want to sort of close that gap and bring them together as we continue to activate low altitude airspace. Next slide. So the purpose of this slide is really to say, part of the other reason that we want to engage with the planning process is because I believe it is deeply linked to public acceptance. So unlike other transportation technologies of the last 10 years, where we went through sort of a dockless model, UAM will require fixed location infrastructure and location-based decision-making. And part of what that does is it triggers the public process. The planning process is generally wrapped around the public, and all of those stakeholders are wrapped around it in some form or fashion. So each of these different steps of the planning process on the outer ring, right, are tied to the stakeholders who lead them inside of here, and that, again, everything sort of funnels back to the public process. And so I I believe that part of public acceptance is ensuring that people aren't just tolerating us, but they are supporting us in the communities that we aspire to serve. Next slide. We're going to talk a little bit about roles and responsibilities, sort of outside of airspace and the FAA. So there's multiple steps to transportation planning in particular. So every sort of general plan has a circulation or what they might call mobility or transportation element, and that sort of process starts all the way up at the federal level, where we've made trigger NEPA or the National Environmental Protection Act. We'll have state environmental protection agencies who will determine scope and impacts of required mitigations for projects. State DOTs also have a fundamental role in preparing and maintaining those long-range transportation plans, developing the statewide plan and the improvement plans every 4 years, involving the public, and they're also deeply tied to aviation planning. Next slide. We also then kind of get more to the what you might call regional planning level and the city planning level. So you have metropolitan planning organizations. These are decision-making bodies that generally oversee the metropolitan transportation plan and the transportation improvement plan, right? It sort of syncs up the state improvement plan. And then it goes all the way down to local governments, where you have the city planning departments that are really in charge of developing, integrating, and approving those mobility and transportation or circulation plans into what we call the general, the comprehensive plan, depending on where you are in the country. You also then have boards of commissions, where they are designed to basically serve as appeals boards. So again, the point here is to really say there are a lot of different folks involved in the planning process, and I think, you know, we can think about how UAM fits into each of these sort of jurisdictions or organizational responsibilities. Next slide. And again, the reason I sort of have stressed both the planning process and the roles and what those different plans look like is because in order to get this sort of elusive goal of public funding, right, you generally have to be included in one of these plans in order to establish eligibility for projects seeking public dollars. Funding can be derived from a lot of different places, depending on whether or not you're looking at federal government, state, local, or private sector. States and local entities generally use different forms of tax measures or permitting. As you get sort of to the federal level, it tends to be a more grant-based grant award system. You also have sort of a pay-as-you-go models that we see emerging in a few different areas of transportation. And you also have innovative finance, right? That's really focused on recovering and reinvesting land value increases that result from public investment and government actions. And I lay this out because I think one of the aspects of community integration that is important is how we build capacity across all of these different agencies that may or may not have had experience with UAM or AAM. And as we build that capacity and as they have potential roles in administering this system, right, there has to be some sort of revenue that comes back to them to sustain the staff time and the resources required to do so. So I think one way or another, you know, it is a question that tends to come up when we're thinking about community planning exercises and how we're going to create a sustainable system within that planning framework. Next slide. And what does this mean for all of us? I think it generally means we have to demonstrate impact. We have to win the hearts and minds of both decision makers and the public, as sort of Adam referenced in his last presentation, that we have a lot of stakeholders to collaborate with, and that we have to take that planning process seriously if we want to be successful, I think, on scale and with sort of the view of an optimized mobility system. So I'll talk just for a couple more minutes about how we're tackling the planning process and how we see that. Next slide. So UAM integration cities, I sort of see it as, this is a much less attractive Venn diagram than the ones you just saw, but generally, how do we balance demand, who wants to go and where, with that sort of supportive jurisdictional and regulatory environment, and where does the technology really enable us to go that you potentially haven't been able to access before or haven't been able to do so on the scale or at the speed that you haven't been able to before. Next slide. And to effectively get to that integration, we really try and focus on confronting challenges and concerns of our city stakeholders when we're thinking about enabling the UAM marketplace. Rather than sort of dance around it, how do we go ahead and sort of head on say, what does funding look like? Why do we have conflicting timelines at times? What are those roles and responsibilities as we, evolve the low altitude airspace, sort of, and the number of different folks inside of that airspace? Regulation is obviously a huge point here, both within aircraft certification, and of course, then as we talked about beyond, as you move to city implementation. And then there's of course questions of demand. Who will this be for? And what does that mean, all of this for public acceptance? Sorry. And then we try and, of course, always sort of go back to illuminating and demonstrating what are those benefits, what do they stand to gain, so that we can articulate the value proposition of these important things. Next slide. So I think what this means for us is that there's fundamentally, we have a lot of different points of industry progress. That said, I think there's a few different areas where we really want to focus in and sort of lean in informing how this system comes together. And that includes setting up sort of a clear pathway for infrastructure development, building public awareness and capacity across those agencies to make sure that people are prepared for aviation, especially where they haven't been traditionally, like at a city level. And of course, there's consumer acceptance baked into that. There's also clarity on multi-jurisdictional governance and coordination that I think is still an evolving kind of question around, again, roles and responsibilities. Who's going to take on what as the system scales? And of course, as Adam stressed, that roadmap to multi-modal integration. How do we make this a fundamental part of the ecosystem in a way that contributes to the optimization of the transportation system, rather than just more stuff on the road, or in the sky in this case? Next slide. So I generally see city integration, what does success look like, in sort of three different phases. I think we have to focus, of course, on mobilizing all of the different parts of the ecosystem and bring them together at the site of implementation towards inclusive engagement with the public and demonstration opportunities, giving people the look, touch, and feel of what's going to be happening. And at the same time, building capacity and tools so that planners can actually integrate this into their planning framework. That will help us get towards enabling policy, modeling, then simulating the impacts of this particular technology, and give us a good platform to actually test and measure those impacts, give us a baseline to test and measure against once we're operational and we've actually got this flying. Next slide. So I probably don't need to stress this too much, but it definitely will take a village to enable this particular market, and whether that's on the public or the private sector, I think it's an ecosystem approach. And I think we can borrow from the collaborative planning framework, next slide, that has really characterized a diverse set of stakeholder engagements to ensure that we're successful. So again, that means reaching out to other parts of the transportation planning framework and environment and ecosystem so that we're integrated into that mobility marketplace. Next slide. Here at Hyundai, we are, again, trying to really take a partnerships-based approach to developing that mobility ecosystem, focusing on driving collaboration, capturing transportation's true benefits, and always with the framework of being both economically and environmentally sustainable. Next slide. So I'll talk about a couple of different projects that we've been working on. We have been working with the City of Los Angeles on a sort of first of its kind UAM partnership, really with the goal of socializing and visualizing UAM, developing some city-specific strategies and supporting the development of technical processes, policies, so that we can really get the resources and best practices towards implementation, really with sort of two goals in mind. One is to reduce the overall workload, right, on every other city who has to take this on, but also help promote some of that standardization and interoperability across our cities. I think we do believe that, for the market to come together and to scale, we want it to come together for everyone. And I think, especially as you look at public dollars and their allocation, it'll frequently have to be toward more technology agnostic infrastructure. Next slide. We're also sort of getting to that look, touch, and feel. We are partnering with urban airports in the United Kingdom under a grant from the UK Research and Innovation Agency. And it's really to actually demonstrate what one of these vertiports can look like in a live environment. So that'll be up and going in December, and we're really excited to really be able to invite people to the table and to start experiencing what I think is going to be one of the sort of most impactful aspects of the AAM ecosystem, which is the infrastructure that people will be housing in their neighborhoods. Next slide. Planning also takes place at multiple levels. And so we are trying to engage in a whole a host of different types of opportunities that allow us to engage in that planning process. We're working right now with the Canadian Advanced Air Mobility Consortium on developing a national master plan along with other industry stakeholders, and really with two sort of guiding frameworks in mind, so we can make sure that, again, we're sort of developing usable, high utility content. How can we create value for federal regulators in Canada through this exercise? And how can we think about whatever our deliverable is as being usable by TC, or Transport Canada, NAV Canada, and the cities that are actually going to be those sites of implementation, right? So how do we focus those master plan findings around the actual effective planning processes, strategies, and objectives that our regulators have? Next slide. And then finally, I'll just say that, I don't think planning always means engaging in a technical process as well, right? So there is an element of just trying to raise visibility and bring partners together in different forums. We did this recently in the Pacific Northwest in partnership with AUVSI and the ACES Northwest Network. But again, how do we bring all of these different folks together within the industry and the ecosystem as building blocks towards a really comprehensive, robust, and inclusive planning process? And so we're looking forward to continuing these types of engagements with partners all across the globe. And next slide. That's it for me. Please feel free to reach out on LinkedIn or by email, and looking forward to collaborating with different folks in the audience. Thanks, Yolanda.
Adrian, thank you so much. That was a fabulous explanation of the planning process, which is so important to all of this. And now we're going to turn to Scott Gore. Scott is the Program Manager for Strategic Engagement in the FAA's UAS Integration Office. And in this role, he leads strategic and community engagement efforts related to unmanned aircraft and the emerging advanced air mobility sector. Prior to his current role, Scott was a senior congressional liaison for the FAA. Scott, I will turn it over to you.
All right, great. Thanks, Yolanda, and thanks for inviting me to participate in this session today. It's a fantastic topic, one that I'm really passionate about, and certainly the right time to be considering these kinds of community-focused topics while we're in the developmental stage for AAM technology. As Yolanda said, I work in the UAS Integration Office at the FAA, and the role of our office is to serve as kind of a program management capacity for the entire agency, moving the whole agency forward on safe and secure integration of unmanned aircraft as well as the emerging advanced air mobility operations. I have a couple of slides just to share as a baseline, and I'll try to keep kind of brief so we can get into Q&A. Of course, at the FAA, our primary mission is aviation safety. I'm sure everyone is well aware of that. Within that safety mission, we have, we think of the community integration aspects of AAM to be just as important as the core safety components of AAM. You can go to the next slide. We have 5 pillars guiding the agency's AAM work, and community is one of those 5 pillars that you see in the slide. The other 4 being aircraft, airspace, operations, meaning the company and the operational aspects of the flights and the operations, and the infrastructure on the ground. And then community is our 5th pillar. Some of my co-panelists have said in the past, and I agree, we can all collectively figure out the safety aspects of AAM, and that work is well underway. However, if we don't integrate this new form of aviation smartly into existing cities and existing regions, then we may not have accomplished very much overall. And aviation's always been about collaboration, a long history of safely integrating new technologies into the national airspace system. And I'm confident that with AAM, that'll be just the next phase in that evolution and collaboration. So some overarching updates, you can go to the next slide. Some overarching updates within the advanced air mobility realm from the FAA. We have a new AAM Integration Executive Council that we just recently stood up to provide senior leadership guidance and coordination across the agency on AAM activities. The acronyms in each of those boxes that you see denote the office, or which FAA offices are included in that. So the executive lead AUS, that's the office that I work in, the UAS integration office. We have executive representation from, starting on the top left, our air traffic organization, going across Office of Airports, aviation safety, our security and hazardous materials safety organization, and then in the bottom row, policy on the far left, counsel's office, government affairs, and our Office of Communications at the FAA. And so that's a great new kind of forum internally that we have at the FAA to guide the agency's work on our AAM activities and leadership awareness and visibility. You can go to the next slide. I'm going to focus a little on the infrastructure pillar that I mentioned. So I think that's the most relevant to community integration sort of topics. Our Office of Airports team is actively conducting research and developing interim safety standards for vertiports. We do have existing guidance for heliports, although given the unique aspects of AAM aircraft, vertiports are going to be somewhat different than traditional heliports. Such things as electric charging and electrical storage systems, for example. So we have a lot of research ongoing. We hope to publish interim guidance within the next 12 months. And then longer term, our Office of Airports team would put out a advisory circular on vertiport design. But for the interim guidance, we do expect that within the next year, hope to have a draft of that out in early 2022 for comment, and then publish a draft, or I'm sorry, an engineering brief that would be the interim guidance by approximately June 2022. You can go to the next slide. So I just wanted to touch on our current regulations that apply to vertiport development, because I think those are also very important when we talk about community integration. We do have existing regulations that cover some aspects of AAM overall and vertiport. We have our Part 77 and Part 157 regulations. Part 77 covers obstruction evaluation standards and the process for FAA to conduct aeronautical studies. Part 157 is the requirements for proponents to notify the FAA about a construction of any new airport, a new heliport, or a new vertiport, or any other type of takeoff and landing area. The other thing I should have mentioned at the outset, our view is that the overall existing regulatory framework will support the AAM industry's goals and efforts to achieve at least their near-term goals and the near-term operations for advanced air mobility. And so that overarching regulatory framework includes everything from aircraft certification processes to air traffic control, airspace classifications, pilot certification, operating certifications for companies. So that's one of our foundational assumptions. We're not expecting any new AAM specific rulemaking. And then on the slide here, I wanted to just focus on the vertiport side of it, since that's, I think, the most relevant for community integration. So again, those are two of our parts listed at the top that in the current regulations that establish the processes to ensure the FAA has all the information to assess the proposed vertiport facility, the surrounding airspace, and any impacts to the existing national airspace system. For an on-airport project, that has one set of requirements for notifying the FAA at least 45 days before construction begins. And for a new vertiport, that would be a brand new facility not located within an existing airport. That's a 90-day requirement in advance of construction beginning to notify the FAA about that work. And until we have those interim standards, safety standards that I mentioned, due out about a year from now, that review likely to be conducted in a two-step process. The first being an airspace review of the proposed facility and the surrounding area, and then a second layer that's a review of the actual facility footprint on the ground. And then Part 157 also does contain a requirement for notifying the FAA upon completion of an airport and submitting what's known as an airport master record to the FAA within 15 days of completion. So those are the initial processes and regulations that AAM proponents would need to complete to develop a vertiport in their region. And it could be a local community that takes the lead on completing those steps with the FAA, or it could be an industry stakeholder that leads those efforts as well. The FAA is open to working with all stakeholders on these kinds of efforts and work. So go ahead into the next slide. So just a little more on kind of community engagement and community integration. As I mentioned earlier, aviation has always been about collaboration. And from my perspective, and I think Adrian alluded to this as well, that's the only way that AAM will come to fruition, is if all the stakeholders work together as a community and collaborate. We absolutely see that as essential to enabling AAM initial operations. The FAA and NASA co-lead an AAM community integration working group that we would encourage any interested stakeholders to get involved in. And then there's some other AAM ecosystem working groups as well, besides community integration. There's, I think, working groups on aerospace, aircraft, and a cross-cutting working group as well. And we encourage cities, municipalities, and I'll go ahead to the next slide. We would encourage cities, municipalities, and industry to engage early with the FAA in the planning process to discuss potential vertiport locations, routes, and any other AAM infrastructure. That early engagement and collaboration is essential, especially while we're at this early nascent stage of AAM development. The Office of Airports within the FAA is the primary points of contact and primary focal point for those kinds of discussions. And they'll engage with other FAA offices as needed. And even in advance of a local government or an industry partner submitting the required notifications and data to the FAA, we want to engage early as plans come together so that all the stakeholders are at the table and can collaborate before things get sort of too far down a path without any input from the agency. My motto is always trying to work together and collaborate and address any issues or challenges before they turn into problems later down the road. Our Office of Airports team has field offices throughout the country. Each typically has a geographic responsibility covering a couple of states each for each of those field offices. In addition to our airports team, though, we also have regional administrators in each of the 9 FAA regions that lead cross-organizational and cross-functional work within the agency. So they're also good points of contact for any proponents or any local communities or industry stakeholders looking to work with the FAA and engage on AAM concepts or projects. At the FAA headquarters level, the UAS Integration Office that I work in leads our AAM work involving multiple lines of business at the FAA headquarters level. And we can go ahead to the next slide. And then there's my contact information. We would again absolutely just encourage the early engagement, early outreach, and communication with the FAA as industry and local communities are looking to integrate AAM technology into their regions. As my other panelists mentioned, it needs to be part of the planning processes early because those local planning processes take a lot of time, and so AAM should be considered as part of those efforts early. So I'll stop there, and happy to take questions. And you can follow up with either from the FAA side if you'd like to follow up with either myself or my colleague David Dunning, who also serves in the UAS Integration Office with me. So Yolanda, back to you.
Great, thank you, Scott. Thanks for taking us through that, and it's been great to have you in this position and have a great point of contact to work with at the FAA. Let's see, I'll invite Adrian to join us again. There she is. So thank you, all three of you, for your presentations, and we'll turn to Q&A and discussion. We have a couple of questions in the Q&A box. I'll just remind our audience to feel free to add more. Let's run through these, and then I've got some discussion points for us. So the first question, I think, Adrian, goes to you, and that is, does Hyundai partner with other eVTOL vehicle companies, or have they already finalized their vehicle?
It's a great question. I know that I can't necessarily speak to the vehicle development side of things because that sits pretty squarely with the R&D team and the engineering team, but I know that from sort of a partnerships and a policy perspective, we have been very focused on creating partnerships across different eVTOL, both sort of developers and operators, especially around pushing or sort of advocating for different types of legislation or enabling policy that sort of has mutual and overlapping benefits for all of us. But I can, if you want to shoot me look at questions from an email or LinkedIn message, I can also link you up with the vehicle team to get a little bit more detail on that side.
Great. The other question we have in the Q&A box is, oh, got a couple more. Okay, what is the anticipated number of AAM units operating in the market? For instance, Los Angeles in 2030 or 2035, or do you have broader estimates nationwide? Does anybody have any estimates on that?
I do somewhere. I do not know it off the top of my head. I would have to go into a spreadsheet. But yeah, no, I'm sorry. I'd have to go into a bit of a spreadsheet. I think we're definitely, I'll just say from a timing perspective, looking at a scale change, you know, around 2027, 2028, 2029, based on where we are. But maybe Adam has something to contribute there.
So, Yolanka, our NASA market study actually concluded that in the U.S., that AAM could have a passenger demand of 82,000 passengers daily, with 4,000 4- to 5-seat aircraft, with a market valuation of $2.5 billion US. What I'll do is I will put a link to the short version of that study so people can read more about it. I'll put that in the chat.
Perfect. Thanks. Scott, did you have any comments on that question?
Nope, nothing else.
Okay, then Scott, the next question is for you. Is the FAA considering a new category for use case besides public and private, such as commercial, thus allowing the FAA to have legal oversight versus how private use currently has no legal oversight capability?
So I think that if that question is referring to like a public use vertiport or you know, similar to like public use airport versus a private use airport, I think that question is about whether
that's the gist of the question.
Third category. Yeah, and not to my knowledge, I don't think there's any consideration of that that's ongoing at the moment. And developing that kind of a third category that was more specific to AM may even require statutory changes from Congress rather than even just regulatory changes from the FAA if we wanted to go down that route. So not that I've heard, certainly something that could be explored further, but I don't think there's any activity in that realm at the moment.
Okay, great. Thank you. So the first question I would like to pose for the panel is around vertiports. You've all talked about various aspects of vertiports. So within this group, I think let's talk about what it really looks like to plan and build a vertiport from the perspective of the local government, from the perspective of OEMs and industry, and from the perspective of the FAA. Adrian, you alluded to the multiple roles and responsibilities, the multiple perspectives. Adam, you touched on equity, and Scott's got his cat visiting him. And Scott, of course, FAA has its regulations around locating infrastructure as well as managing and protecting airspace. So I'd like to open it up a little bit. Anybody can start, but let's. I have the three of you. Let's talk about a little bit more about what that looks like and what roles and responsibilities we need to be thinking about. Anybody want to jump in?
Well, I'm happy to start on that, Yolanka. I think from the FAA's perspective, as everyone knows, our role is ensuring safety in both the airspace and on the ground from aviation activity, and AAM is a new form of that. And the airspace is quite busy across the country in many of the same locations that AAM and urban air mobility. That's one of the use cases, not the only use case. Where this kind of technology is proposed to be integrated. And so we need to first and foremost ensure that it's done safely, and at the same time ensure that it's done smartly to be integrated with existing transportation systems, and considering all the community and local governance and local procedures and permitting that can be different from location to location. But safety has to be, I think, a primary consideration as well, so that this market, this industry can kind of be viable for the long term.
Yeah, I'll also just chime in. I mean, I think about sort of 5 different buckets that are going to be sort of critical for us to take on, and sort of as an OEM, I think we have obviously a lot of stake in the game of these being successful. And so as much as we can, being proactive partners in pushing sort of the development of best practices and guidance. But I think, there's obviously a need to sort of define on and off airport vertiport design standards and what that common use framework might look like, right? How we get that practical guidance. Infrastructure funding, how do we think about existing programs and potential inputs to modernize and rebalance? How do we think about the way that we contextualize this new opportunity within the existing funding kind of landscape? There's state and, I've talked extensively about the state and community land use planning. And so on our side, that may look more like vertiport site identification, but really trying to work within the context of existing transportation plans to think about where that vertiport site identification is going to be highest best use. Advocating for local zoning changes as needed. That may look like a vertiport overlay zoning, but other methods that we're going to need to develop to manage compatibility, safety, and security, right, to some of Scott's points. And I think there's probably, a component of low altitude flight routing. Right? How is this actually going to look when push comes to shove? And what is the process for developing that? And each of these will sort of lead us to the planning process itself. Those are sort of the buckets I think about we need to be anticipatorily engaged on.
Adam, you must have some thoughts.
I agree. Yeah, I agree completely with everything others have said. I think when we start looking at kind of vertiports, we need to be thinking in terms of, different size of facilities, different types of operations. We haven't even really gotten into a lot of the ancillary services that are going to have to support vertiports. We may have needs for off-site charging or refueling, off-site maintenance needs. All of those also kind of fit into this bucket of vertiports, even though they may or may not serve, passenger volumes. And so I think we need to start thinking about that. And also remember that not every site is necessarily going to be a perfect place for a vertiport. It's going to be a balancing act of different sorts of competing interests. We want it, close to transit. We want it, close to people's origin and destinations. But we also want to make sure that it's sensitive to surrounding land uses and that it fits in and appropriate in the built environment. So I think there's going to be a lot of different factors that come into play.
Anyone else have any comments on that? Adrian, you're muted.
Yeah, I think one thing that is important to sort of stress here is that I think we have to be prepared to stop thinking about, and I know, I've probably touched on this in independent conversations, but, as an OEM, I definitely, we're coming from that OEM space, I think we have to stop looking at public acceptance as sort of an exercise that we have to go through to get people to tolerate the industry and think about how we build support. And I think the overall planning process and implementation of UAM will be much more successful if we can reposition that conversation around how do we best reach the people that we aspire to serve and the communities that we aspire to serve, and start reframing them as communities versus a sort of a headache that we have to get through. And that will, I think, in many ways, especially at the state and local level, I'll say, that will give us a significantly better relationship, I think, with planners and with the government decision makers, if we can both reposition around that sort of framework and at the same time produce more technical information about what the true impact and sort of impact evaluation framework is going to look like for this particular industry. Yeah, and so sort of driving in on capturing what the true value is and making sure that we're communicating that early and with the goal of sort of building support, not just tolerance, I think will be key for us.
So I'm hearing education and communication as significant pieces to this, and as well as collaboration. I know, certainly at CAMI, one of our goals is to bring local planners and decision makers together, recognizing that it benefits everybody if we can build that peer network and have an opportunity to build some model policies and best practices that work across locations. It's good for industry not to have to deal with a different set of criteria in every location, and it's good to strengthen the voice of local communities around this new industry. Adrian, you kind of cued me into my next question, which was really about how approaching public acceptance. And I know you and I agree on this, that this is not just something that we have to do. It's not just a checklist. What does it actually mean? And I think all of you and a lot of people have heard me talk about how this has been a technology push market to date, this convergence of these technologies that have created this opportunity. But now we need to go to the other side. We need to look at the demand side and really understand what are the opportunities that this new form of transportation can bring to a community or a region, and how do we have that conversation? So let's talk a few minutes about what that public engagement process can look like. That's a positive and constructive opportunity.
And Yolanda, I have to jump off here in a minute because I'm at another conference presentation. But I'll just say, I think from our perspective, this relates to sort of multiple tools, and I think some of the strongest have to do with visualization, simulation, and demonstration. How do we get people to look, touch, and feel? And how do we do that using creative sort of technology approaches so that people can digest it before they're actually going to get into one of these, right? And I think that's important from both planning perspective, but also just how you reach the public.
Not just get into one, but even make a decision on whether there should be a vertiport in their neighborhood. Right. Well, Adrian, if we're going to lose you, thank you so much. And I'll turn the question to Scott and Adam to see if they have comments about that.
Thanks, Yolanda. I mean, I think we need to start, shifting the conversation from public involvement to community empowerment. Involvement was kind of this kind of passé idea that, we're going to listen to the public, they're going to submit a public comment, and that's kind of their input. And I think, more recently, we've really kind of have moved to this idea of empowering communities in the decision-making process, letting them kind of engage earlier in kind of the feedback in terms of where vertiports are located, how they're designed. And I think, we need to start talking about kind of engagement and empowerment and less about kind of involvement, because I think we're talking about a deeper level of engagement.
Great, thanks. Scott, do you want to add to the conversation?
Sure. Yeah, I agree 100%, Adam. And I think that's I may use that in the future. I think community empowerment is a great phrase and a great way to think about the role that communities have in the AAM ecosystem. Because from the FAA's perspective, it's public acceptance or even integration. That can be a challenging concept to try to quantify. It can be very subjective, and it's also not even clear, at our level at the FAA, what the formal public processes are going to be for AAM development. It's a lot of times, those types of formal community or formal public awareness and public involvement processes are triggered by things like NEPA or the FAA's grant assurances for airports, and then vertiports won't have any of those sorts of things. Or Part 139 airports that the FAA certificates are large airports. Vertiports won't be Part 139 certificated. So it's not entirely clear what processes at the federal level would be triggered to when we talk about community involvement or public involvement. So I think it really does come down to community empowerment, as you mentioned, that's more driven at the local level or from the business community to work with the stakeholders in the regions that they hope to provide service to.
Well, thank you. We are out of time, so I want to thank Adam, Scott, and Adrian for participating in this panel. It's always a pleasure to have a conversation with you all about this topic, which is near and dear to all our hearts. And I will take off my CAMI hat and put on my Cafe Foundation hat, and thank all the audience for being here with us today, for your questions and comments. We look forward to 2 more days of the Electric Aircraft Symposium. If you registered just for today, it's not too late. You can go, Jim or Mike or Chris, if you would pop the registration link into the chat, you could still go register for tomorrow and Thursday, and you'll find the agendas and speakers on either Vertical Flight Society's website or on the conference website, electricaircraftsymposium.org. So we hope you will join us. And with that, I'll just pause to see if anyone from Vertical Flight Society has any comments. Otherwise, we will see you tomorrow.
Okay, just put the link to register in the chat, just in case you are only registered for the first day and would like to attend on Wednesday and Thursday.